Check. Good morning. This is a check. A very good morning to all the participants. In few minutes, we are about to start the session. A very warm welcome to all the participants for today's session. Today, our session is about regression. So, this session is given by Dr. D. Ramesh, IIT Dhanbad. Sir is going to deliver the talk on linear regression techniques. So, I would like to invite Dr. D. Ramesh Garu, IIT Dhanbad, to take over the session. And before that, I'm going to introduce our today's session speaker, Dr. D. Ramesh Garu. Dr. D. Ramesh Garu received BTech degree from KITS Varangal, Kakatiya University, Varangal in 2004 and MTech degree with specialization as software engineering from JNTU Hyderabad in 2009. After his graduation, he joined International Trade Links and served as a database developer at various client offices in South Africa, Dubai, and United States. He received PhD degree from Indian Institute of Technology, ISM, Dhanbad in 2015. He works and publishes widely in the areas of distributed databases, cloud computing, modeling, big data, blockchain, and brain computer interface. He has published more than 47 reputed articles in various international journals, 17 book chapters, 2 books, and 40 peer reviewed international conference papers in India and abroad. He has also published a book on atomicity and snapshot isolation on column oriented databases, a transaction approach, and number of book chapters in various books by standard publishers such as Springer and Tata McGraw. He visited reputed international universities like Spain, Italy, United States, United Kingdom, and Amsterdam as a collaborator and speaker at various venues. He delivered keynote talks at various international forums. He is the chair, editor, and reviewer of various international journals such as Elsevier, Springer, IEEE, and Tyler and Francis. He is currently served as top hierarchy assistant professor at the Department of Computer Science and Engineering, Indian Institute of Technology, ISM, Dhanbad. He is a senior member of the IEEE and a member of ACM, ISTE, IAENG, and also an editorial board member and potential reviewer of various international journals. Dr. D. Ramesh Garu received Best Paper Award for the paper Correlated High Average Utility Item Mining, and he also received Empowerment and Equity Opportunities for Excellence in Science for the project Machine Learning Based Agricultural Advent for the Farmer Activity Development in India. Dr. D. Ramesh Garu received Best Researcher of the Year 2018 International Award. Dr. D. Ramesh Garu received Outstanding Scientist in a Computer Science 2018 International Award, Venus International Foundation, India. Ramesh Garu received Early Career Research Award for the project Precision Agriculture Model to increase crop productivity in India using big data. And Dr. D. Ramesh Garu received a Best Paper Award for the paper IDPC XML Integrated Data Provenance Capture in XML. Ramesh Garu also received a Best Paper Award for the paper Accelerating Airline Delay Prediction Based CUDA Computing Environment at International Conference. Dr. D. Ramesh Garu also received Best Paper Award for the paper An Integrated Query Processing Approach for Transaction Protocols in Heterogeneous Distributed Database Environment. With this long list of achievements and glory, I would like to invite today's session speaker, Dr. D. Ramesh Garu from IIT Dhanbad. Sir, we welcome you for this session, sir.
Yeah,
Thank you
yeah.
so much,
Thank
and
you.
I request you to take over the session. Ramesh
Yeah,
Garu, please.
yeah. Thank you, Ms. Revati, for your kind
Thank you.
introduction.
Yeah.
Yeah, and I could see that good number of participants are there in today's session. Okay. Yeah, please bear with me that due to the winter season, that I'm feeling some kind of cough related issues. So probably that it may disturb you in between. But please don't mind and please bear with me. Okay, for uh, a complete session. Okay. Yeah. Uh, First of all, thank you very much for considering me and inviting me as a speaker for this AICT sponsored STTP. Okay, so I have been told to deliver a lecture on regression type of regression type of strategies and some models, so that the learners can start their uh, utilization or something. Learners can start their uh, uh, strategies that the same can be applied in their further research, if I feel. And the guys we have already worked on, and again if they would like to further extend, especially in machine learning and others, they can apply this kind of concept anywhere, like medical field and even agriculture field, and lot many fields are there that you can apply anywhere this concept. Okay, so I'll start with some basic preliminary concepts of regression model, and I'll go through the entire part of that regression models, and I'll try to introduce you the mathematical standards that which are really required for us to have good number of calculations, so that the exact accuracy can be measured, or not accuracy, that nearby kind of accuracy can be measured, and same can be predicted for future purpose. Okay, so that's what this is about my talk. And can I switch off my video if you don't mind? Yeah. Yeah, thank you very much. Fine then. Okay. Yeah. Okay. I'm sharing the slide first. Then let me discuss the preliminary issues of linear regression model first. Okay, and after that I'll let you know that in what way the methodological aspects of regression can be applied to the industry or application type of issues. Okay, so if I consider the concept of business forecasting, that I'm keeping in my mind, like that business forecasting and planning. For this, that I'll be discussing this simple, not simple, that some regression related techniques, so that the optimality of means usage of linear regression technique can be used up to the optimum levels. That's it. Okay. Yeah. I think my screen is visible to you, right?
Yes, sir. It is visible, sir.
Yeah. Thank you. Yeah. So let me just, guys, then basically we don't rely on theory, and even we don't believe in theory, right? So whatever the model we consider, we definitely try to simulate the same by considering various aspects in and around of that particular mathematical equation, right? Why? Because see that we have given the possibility that after some point, if something goes wrong with that particular model, yes, this is a kind of invention, like that we can simply say that you should not go like this. So if I give a best example to you, like that, I'm completely relying on Google Map.
Sir,
Okay,
sir, please put in the full slide mode, full screen mode, sir.
Yeah, it's okay. It's okay. Okay.
Thank you, sir.
Yeah. So that I can start with a basic example, right? That so that you can understand that where exactly the concept of the same can be applicable. Yeah, is it okay now? Okay. Fine.
No, sir. No, sir. Slideshow. Please keep in slideshow.
Yes, I did. This I did. This I did. I think my entire screen is visible to you. Then I made it.
No, sir, it is not visible. I mean,
Okay, just wait.
The slide.
slideshow. Yeah.
Just,
We are able to see all the slides at left side, sir, in indexing manner,
okay.
apart from full screen mode.
Sir, could you please keep F5, sir?
Fine now? It's fine now?
No, sir.
Sir, please press F5, sir.
No, it's the same that I'm watching the full screen on my screen.
Okay.
No, slide is not visible, sir, here.
Yeah, just wait then. Okay, then let me reshare the same. Otherwise, then I have to do something.
Idi kada. Idi.
Is it okay at least?
Okay, sir. Somewhat better. than
Yeah,
previous.
but I have not included that. Let me discuss, and then if you feel difficulty, then let me elaborate the same. Okay.
No problem, sir. Carry on. Thank
Fine.
you.
Okay. Yeah. So let me start with one basic example that I'm completely relying upon the Google Map. That where I was standing in New Jersey and waiting for a taxi, right? Taxi, and yeah, then after some time, then even I could not able to observe any arrival of a taxi towards my standing location. Okay, so what I did then, even I started searching for the hubs of individual taxis, and accordingly I started moving towards. Okay, finally I could find uh, the taxi stand, and I have booked finally. Then that I have given a location to the particular driver. Then my I supposed to reach a location which is means nearby sea. Okay, a big sea. Then that sea was means having some combined combined bridges up to some extent. Then one of beside one of bridge that I supposed to reach the location. So what happened that when I gave my address, that taxi started moving towards the location. But what the Google was showing, that I mentioned say bridge A1. Then that bridge A1 and that bridge A1 is the combination of some pillars. Okay. Then I have reached my location, but that Google is not able to stop the taxi, and yeah, okay, then let me reshare. Then after some time, don't worry. Okay, just wait. Just wait, okay. It is creating some issue, I believe. Okay, just wait. Then I'll do. I don't know what's happening with you guys, especially.
Okay, sir.
It looks fine from my end, and we are doing every day for our students in the form of Google Classroom. Yeah, anyways, okay, then let me do with this, I believe. And yeah, is it okay now? Then yeah, it's okay.
Yes, sir. Yes, sir.
Yeah, fine then. Yeah, okay.
Keep it in full screen mode, sir.
No, that I have already kept as F5, and
Okay,
don't know
then increase the size of the screen if possible.
I have I have
What we are seeing is 25% we are seeing at left side in a vertical order of all the slides, and right side 60% of your slide is visible.
no, but
Try to
okay, this
increase
is
it.
anyways,
Yeah.
this is visible to you, right?
Yeah, visible, sir. It is visible.
Yeah, then no issue. Anyways, okay, please let me do with in a normal way, so that we can proceed further with actual content without wasting our time. Yeah. So what happened? In the similar fashion, the taxi could not able to means the taxi software means could not able to relocate my exact location. Means it was showing the extended path towards my destination. Even I have crossed my destination and it was showing the path towards the sea. Even after crossing the bridge, okay, even after crossing the bridge, then definitely that I have to stop somewhere in the means middle of that particular sea. Then why this? Means that even the mathematical model that which is simulated,
Sir,
okay.
sir, your screen is not visible, sir.
Yes, I have
Please
not
check it.
shared. I have not shared.
Okay, okay.
I have not shared. Don't worry. I have not shared it. Okay. Yeah. So it was giving some negative results. Why this is like? Okay, means the kind of prediction went in a wrong way. No, I don't think so. So let me introduce two values. Means two parameters here. Like that, I'm completely depending upon a kind of means location. If the location is if the location is what do you say? If the location is uh, defined with its altitude and others, okay, that would be the issue. Then what happened then? Then am I not able to predict the exact location value due to the uh, optimal simulation of that particular mathematical model which is embedded in the Google map option? Yeah, right. It's a lot many things then finally. Yes, I'll make you everything sure. Just give me 2 minutes that I'm taking login again. Yeah, I have joined again. Then my organization is not allowing outside entries. Then we have a special firewall. Okay, because of that.
Okay, okay, sir.
Yeah,
Okay,
probably. Then okay, that I made it clear now. Then I can do accordingly.
okay. Thank you, sir.
Just wait. Again, some application is creating some problem. I don't know what's happening. Anyways, just give me 2 minutes so that I can resolve the same.
Yeah, dear participants, there is no audio from the Dr. Ramesh sir. We are trying to reach out to Ramesh sir. So please, we'll wait for a few minutes.
Yeah. Sorry for that. Okay.
Yes,
Yeah.
sir. Yeah,
Sorry.
please
So
continue, sir.
yeah. So what happened here? That please let me represent the same. Then representation of some phenomenon like that. How we are going to define a model basically. Then, as I told you, that we frame the theory first, right? And in order to make the theory executable, then we try to simulate the same by using a relevant statistical model, right? Then the model could be of two types, right? Simple, that is deterministic model, and the second one is the probabilistic model. Then, so deterministic model is straightforward. Okay, say that I have stored my details in a store. Okay, cloth Shopee store. Then whenever I visit the Shopee, then whenever my card is cracked, right, then automatically it reveals my data like that. That shirt size is 41, and ultimately the guy will bring 41 size shirt. Then if you consider the case of probabilistic model, then sometimes I can say that I went gym and I developed
Sir,
a body, and because of that
sorry,
reason 41 size is not fit
sir,
to me.
sorry to disturb you, sir. Ramesh sir.
Yeah,
So one of the participant is asking to explain from the beginning.
this is second slide only.
Second slide. Yeah.
Yeah. Okay, this is the
Yeah,
second
sir.
slide only. That
Yeah.
model I'm going
Vaishalini
to,
madam. Yeah. Yeah.
yeah,
Okay,
fine.
sir. Thank you.
Yeah. So if you consider the example of the same, that uh, the taxi prediction, address prediction by the taxi, then if the algorithmic approach might have gone in a clear cut way, that then that model would be treated as a deterministic model, so that I could reach my exact location, but I couldn't reach. No, means some problem was there, means some extra parameters have been included in that, right? So what the Google algorithm did, that as I was mentioning, that A1 bridge, that A1 is having some sub pillars, and that each and every sub pillar is located with their own entity, right? So A1 with 1 like hyphen 1, A1 with 2 hyphen like A1 with 3 like this. So there, that possibility was not included, and that algorithm was updated. Because of that reason, the algorithm could not able to optimize the exact location, right? That was the reason, right? So how we can configure such kind of modalities in a different manner, like say, so this I have kept for uh, that is a medical field, that I'm not going to discuss this one, that I have already explained. A straightforward model, that is deterministic and probabilistic. That okay, that's simple, straightforward. That, yeah. So the problem is with probabilistic models, no, that some kind of parameters have been added. And because of that reason, that the exact value was not predicted in a clear-cut way. Say example that I was quoting one example, that is that I would like to establish the business, and initially I have spent 4 lakhs rupees for advertisement. Then after spending 4 lakhs on advertisement, then my sales got increased and I got the profit of 2 lakhs. 4 lakhs I have spent on advertisement, and 2 lakhs I got as a profit. Now, if I spend 8 lakhs, then what would be the profit I can get? 4 lakhs? Can you predict it exactly? Now, it may increase up to 4.5, who knows? Or it may decrease up to 3.5, who knows? And why this is happening like this? Right? Due to the changes, like some kind of changes in terms of parameters that we call randomness observation. Okay, anyways, then, so the probabilistic models are broadly categorized into 3. Right, that which we are discussing, the leftmost part, that regression models, correlation models, and other models, right? So if I speak about regression models, like, yeah, sorry, Just as I told you, that relationship between one dependent variable and explanatory variable, that is independent. That use equation to set up relationship, right? Like numerical dependent and response variable, one or more numerical or categorical independent explanatory variables that used mainly for prediction and estimation. So from this, I can give you one exact definition of regression. Like regression is a kind of strategy, right, which gives us the possibility to estimate or predict, right? Estimate or predict. These two are vice versa. That prediction followed by estimation or estimation followed by prediction, right? That regression is a kind of strategy, right, which gives us the possibility to predict or estimate, right? Estimate the whether it is a medical field or agriculture field or computing field or optimization environment, whatever you feel, definitely you'll try to adjust the parameters accordingly. Say example, that like me guys that went to a hospital for checking body mass index, BMI. Okay, then equal is like 38, 38, 38, and weight is also 65, 65, 65. Height is 5.6, 5.6, 5.6, right? And again, blood checking was done, and again the purity found was 95. And these three people goes for jogging every day, and then they takes healthy food. They takes healthy food. Then after checking BMI, right, there was a difference observed, right? There was a difference observed based on the parameters given like this. The parameters are quite common, but why the BMI percentile is showing different, right? Getting no? So this that we are going to this we have estimated, but this is not actual prediction. That why this is happened like. Why this has happened like that? Why the prediction is not equal? And an estimation was like that, as I told you, that I have spent 8 lakhs rupees for advertisement, and I supposed to get say based on 4 lakhs spending, that I supposed to get 4 lakhs as profit, but I'm getting 4.5. Why? Why? Right? Due to some non-linearity observation, like as I'll explain this concept. Okay, yeah. The regression modeling steps are like this then, right? That I can say one important thing here, that the regression model follows some hypothetical observations, or I would rather say hypothetical modalities. Okay, hypothetical modalities. And in the same field, if you try to apply the concept like that, blood percentile checking, or breast cancer checking, okay, or blindness checking, okay, or other type of operations that you'd like to involve, right? So what it gives a chance like that hypothesized deterministic component, which is included in the regression model, that gives us the possibility to estimate unknown parameters. Yes, as I told you, that why the 3 people got different body mass index percentile, in the sense the first guy used to take milk, and the second guy used to take green leaves, right? Where the green leaves gives extra energy and extra protein as compared to milk up to some extent, right? So these are the parameters. So based on these unknown parameters, right, these unknown parameters are not included, like then their food habits have not considered. Because of that reason, the percentile was gained like that, right? So this point, please remember that estimating unknown parameters must be included in order to make the case or hypothesis hypothesis component must be deterministic. Now, as I told you that we are not relying upon what deterministic model, right? Deterministic straightforward. Deterministic is straightforward. That one particular train is having 12 compartments, right? 12 bogies, like then all are AZ, and the seats are 55 per bogie. as usual, the reservation can be done and no extra person will be allowed. So this is deterministic quite. Okay. So in keeping the festival type of rush, two more extra compartments or bogies have been added. Now, then the scenario will be quite difficult. Why? Because 55 that 110 seats must be allocated accordingly. Then what would the priority given to the people like that? They have to maintain all the possibilities like reservation for senior citizen, okay, reservation for handicapped people, reservation for women, like all. See, that if you go beyond the deterministic approach, then this probabilistic situation is creating problem. Why? Because that here the parameters are considered in a randomness manner, not in a random manner, like where the deterministic approach of particular that regression model is having some random modality, where the probabilistic model is not having random consideration. This is a randomness consideration. Because of that reason, right? Because of that reason, this kind of situations are happening. So I vote for the second model, not for first model. I vote for the second model, not for first model, right? So what it includes, one important point here, that if the probabilistic mode distribution of random error model is considered, then we will be given the possibility to estimate standard deviation of error. Excellent modalities. So if you consider the deterministic one, then you try to apply the standard deviation in a straightforward manner. X bar, Y bar, X minus X bar, Y minus Y bar. The values are given, then you take the standard deviation, apply the values directly. Okay. Now, some error is occurred, no? Then how the error can be handled? This is really a difficult task, my dear friends. So, finally, the regression model steps: evaluate the fitted model, then accordingly, then use the model for prediction and estimation. So, we must and should follow these three. Up to some extent, that if this hypothesis a deterministic component is quite fine, then the probability distribution of random error term is specified in a proper manner, then definitely the error can be resolved, and then we can use the model for prediction and estimation in a clear-cut way without feeling any difficulty. Yeah. So what would be the model specification now? Right, specifying the deterministic component I'm speaking. Then I don't want to speak much about, but let me write. So define the dependent variable. The story is running behind whom? The story is running behind dependent variable and independent variable, right? Dependent and independent variable. Say, let me change the modality of the problem, that which I was speaking on. That is advertisement and profit. Okay, advertisement and profit. Now, let me change the modality of this problem in a different way. That till this moment that I felt that that advertisement is the independent variable and profit is the dependent variable. Okay. Let me change the modality now. In what way? That, yeah, till the third step, like I have spent 4 lakhs for advertisement and got 2 lakhs as profit. Now, spent 8 lakhs and got 4 lakhs as 4.5 lakhs as profit. Spent 8 lakhs and got 6.5 lakhs of profit. Now, that in order to get 10 lakhs of profit, that how much money I supposed to spend for advertising. Now, I have changed the modality. Now here, the advertisement variable became dependent now, and the first one, like profit variable, became independent. See, the problem is in our hand. Simple, no? Right. So deterministic is quite common. No need to worry about that. Now the problem is that hypothesized nature of relationship, like the expected effects, like coefficient signs, like. So the functional form should be like linear and non-linear. I'm not bothering about linear, but that I'm bothering about non-linear, right? And that, let's say that how the points are, how the related parameters can be provided, the interactions among. Okay, yeah. So the model specification is based on theory, as I told you. Okay. So let's have the problem formation that in the form of theory that I'm assuming something that I supposed to reach Hyderabad airport from Dhanbad. Then I have so many ways. I have so many ways that I have chosen the flight venue. Okay, I can travel through Ranchi, via Ranchi. I can travel via Kolkata, or I can travel via Durgapur, nearby airport, right? Right, then I supposed to examine this one. So this theory I have in my mind, right? So this I'm calling it like the theory of field, like example epidemiology, right? And that we supposed to frame the same in terms of its mathematical theory, and then we have to take the inputs from the previous research or previous methods considered, and finally we have to apply the common sense. Where the term of common sense comes, right? I have chosen shortest path that is very near, that is Durgapur airport. Then I can reach within 1 hour from my location, IIT Dhanbad to Durgapur, and from there the flight takes only 1 hour 10 minutes to reach the Hyderabad. And after reaching Durgapur airport, I came to know that that flight got delayed by 50 minutes. Say example, let us extend it 1 hour 40 minutes. Now I have changed my modality, that if I could have traveled towards Ranchi, then again that it will take some say extra time, I believe. Now this is completely depending upon me, that whether to choose this option, like I supposed to wait at Durgapur airport, or again I supposed to replan again. So this is common sense. Getting? Yeah, so this is the model specification based on our theory. That, as I told you, that we frame the concept in the form of theory first, and then after that we go for validation. So thinking challenge, that which is more logical, my dear friends, like say these are the thinking optimalities, like it's a kind of conversion happened, like between some people, and see, this is straightforward, and the thinking was quite high, and it gone down, and it replicated some negative results. Now if you think this one, that people stand up to this level with clear-cut ideas, then after that, again due to some degradation, again the logical thinking came down. Now this option, if you consider third option, like, okay, so this is happening in a linear way up to some extent, but yeah, starting from low level thinking and reached up to the level, and finally due to the other parameters applicable, inclusion, again it came down, right? And finally, if you see the last one, right, this is quite linear, that starting exactly from the one of the starting point, and without any downgrades, and directly it is going to the up to the maximum level. So definitely this theory will give us the best idea. Now, but how to capture this then? Okay, yeah. So types of regression models that we need to discuss about, right? So a simple model is a simple regression, and the second one is multiple. Let me tell you the difference here itself, that the simple regression is only one, completely depending upon one explanatory variable, that is completely dependent. Okay, and if we consider the multiple regression, 2 plus explanatory variables, then the probabilistic situation, that which is creating the problems due to randomness, right, that can be evaluated here itself. Okay, multiple, this is given a scope. Then simple is quite easy. As I told you, that I instead of making advertisement variable independent, I made it independent, and up to some extent, that instead of making the profit variable as dependent variable, I made it independent. A simple reason, that's only one. But here, that we need to include more explanatory parts, especially with multiple regression, right? So again, if you consider, that is linear and non-linear both. Right, then I have simply shown you that there is no issue with linear, but there is an issue with non-linear. Right, why? Because due to some parametric changes. Due to some parametric changes. Okay, yeah. And again, this multiple is also linear and a combination of non-linear. Both. Where is the difference? Where's the difference? The difference is that due to the randomness variables, some problematic situation. Say, you can ask me that what is a problematic situation? What is a problematic situation? Say example that say till today that I'm running my car with one single engine. Okay, then after some time that I have deployed, I mean included another engine. Then after that I would like to test the performance of my car. It would be increased. Yes, it would be increased, sure. But what about the consuming of petrol? Okay, what about the speed ratio? What about the wind power it can gain? Why? Because the speed is increasing, no? Then these kind of different parameters definitely having their impact, right, on the model. That's why. Yeah. So let me start with linear regression model. Okay. Yeah. The first one is the linear that I'm speaking about. Simple, my dear friends. Okay. No need to worry about. Here, y is the output variable. Okay, y is the output variable, and x is the input variable. Now you tell me that output variable y is equal to mx plus b is depending upon, like, right? So here y is the dependent variable. If we keep on changing the values of x, then ultimately the scenario of y will be changing. Right, so this is a simple equation that I'm showing for your purpose, like that. So y is equal to mx plus b, that where m is a slope and something that change in x each and every time that is happening, and b is the y intercept. Then okay, it might be a constant, that no need to worry about b, but we need to worry about x. Why? Because this is independent variable and y is a dependent variable. Y is the dependent variable. So if it goes in a clear-cut way, then definitely the linear formation will be observed without any hesitation. If something goes wrong, like say, let me consider the same example, like the profit and others. Profit and others, like say initially I have spent 4 lakhs on the particular product advertisement, and finally I got 2 lakhs profit. Then say after 5 stages, I have spent more, but I couldn't get more than 4 lakhs profit. What would be the reason, my dear friends? What would be the reason? Right? Say a kind of parameter I'm including here, that is similar product came in market with flexibility. So that's why the customers started customers started looking towards. This is the reason, right? So again, we supposed to bother about non-linearity. Yeah, simple reason that let me establish the relation now. So linear regression model, relationship between variables is a linear function. As usual, we know that. So here this y is a dependent variable, as I told you, that dependent, like response variable, like something. And anyways, then that since we have considered the that in keeping the mind like that, we are dealing with probabilistic situation, right? So the error concept is random error concept is involved here. It's up to us. You can eliminate one by one, no issue. That yi is equal to b1 plus b1x, you can do xi, you can do directly, and later on you can include other parameters like that. So y is intercepting time by time. So that's why that's why a constant parameter beta 0 is involved, and random error is involved for various cases, right? And finally, what we need to consider, this is our important consideration, xi. Why? Because this is independent and which has explanatory meaning exactly, right? In this way. So in this way, the relation can be established, like established between the dependent variable and independent variable. This is up to us. Like there is no limit that fixed size of variables, I mean limited, unlimited fixed size of variables can be integrated with such kind of variables, live. Okay, so there is no limit here. And population and sample regression models, we speak that, see, population, that what do you mean by like see, unknown relationship. Say, see, that I would like to, this is the population I have considered in a set space, okay, that I would like to establish the relation, right? Initially, I do not know that what kind of relation exists in between these guys, right? So unknown relationship, simple. So this is y is intercepting, and b naught that I have already discussed here, that is population that intercepting the value, and population slope is b1, some kind of value importance is given in terms of, and this is a random error to some extent, right? So in this way the unknown relationship can be configured. Now that it was found that some random samples have been considered and a kind of relationship has been observed. Random samples. Why? Because these two are very near, might be having, in keeping mind like, so since these two are very near, and due to some common assets, might be having some common parameters type of, some common type of habits, like, right? So this is the one. Now this has been changed from where to where, that yi is same, that still it is depending, my dear friends. Now for these two especially, that b0 is beta 0 is changed to b cap, and b1 is changed to b1 cap, and sigma I, the random error, is changed into sigma I cap. Right, now let us examine the possibilities with different values in terms of random error, like random error. Say I'm saying these two guys are female, okay, and having same age, 21. Their food habits are same, having same color, height is same, okay, height is same, but the first guy takes sleep maximum time. That is not liked by the second guy. So there the difference comes. Now based on this one, that we have been told to examine the energy outcomes of these two. So how can we configure the energy outcome of these two guys like this? So the modality of yi, like, which is changed into b cap, b1 beta cap, b naught cap, and b1 cap, and sigma cap, has been reinstantiated in the form of known relationship now. So once we check the possibility of sample regression, right, that with all possibilities of random errors and changing the modalities, then definitely that we can club these two with this guy, third guy. Then after examining the same, that we can club these three with this guy. Then after examining same, we can club this with these three guy, the last guy, like this. So in this way the modality works. Now if I consider the if I could have considered the probabilistic model, deterministic model, then definitely it would have not been suggested the exact result scenario. Right, this is the way. Yeah, so this has been observed on the scale, and observed value like this. So what happens? 6, no, that okay, 5 I have considered. This is the value, and that the same random error has been examined for this top guy. Then random error, that by I b not some initially observed value is this one. This is the previous value. Okay, now moving on, the changed value is reflecting something. See here, excuse me. So this is replicated in this manner, that this is unknown relationship. Okay, unknown relationship, and the random error is a common random error is declared with a common value. Why? Because relationship is not known. No. Now after examining the possibilities with various parameters, like that I have considered, no, what that is, these two guys are having similar habits except sleeping, right? There it was observed like this. See the observed value, right? And we have observed something here, my dear friends, and see the random error. See, instead of this is the previous one, and now After establishing the relationship between, what happens? See, this guy, see here, this guy became normal and normal. Here, see. So these two are like this, and then where we supposed to keep him? This one, with him or with him, this guy or this guy something, or this guy must be accompanied with whom? Like with this guy, like so. So let's see the observed values. That what happened. So this is the unsampled observation observed with this particular guy, and this is the random error observation, and still this guy persists with the same. Then what we do? We keep on changing the values of b0 cap and b1 cap till the randomness error is satisfied. So finally, the observed value will be fitted into the corresponding modality. So at least I cannot say that 100% accuracy we can achieve between these two, but at least 99 point something we can get. That is less than or equal 100 percentile accuracy we can achieve. Now this is really mesmerizing, no? Yeah. So as I told you, like that how can we estimate these parameters now? Just as I told you that, let me include the parameter like that. Sleeping condition is different for these two guys. So due to this, what's happening though, that after some time this guy became very thick, and due to the hard work and something, okay, as normal living conditions, this guy is still maintaining the structure normal. Now see, the modalities have been changed. So what's happening here? What's happening? If the body size is increasing, then definitely, like there may be a chance of getting illness and the diseases, kind of diseases, right? So we need to consider other parameters too. Then accordingly, what happens? These guys' performance will definitely be degraded. Okay, yeah, this is the consideration. See how I'm framing, means modeling the theory concept towards the modality. Yeah. So let us examine the parameters, and what kind of parameters we need to examine. So without least square models, that we cannot process the component structure of regression. Okay, yeah. So same this is kind of a scatter plot, that what it says, that that plot of all xi yi pairs accordingly, then okay, then suggest how well model will fit. So this is the normal representation, pictorial representation. Now based on this one, see, this is the normal one. Now let me have a kind of linear combination. My question is that, this is the thinking challenge, my dear friends, that how would you draw a line through the points, but how do you determine which line fits best? Then why don't I start from 40 to like this, in a downgrade way, like this? Even I can separate, no, that these three and these three, right? Why? So the sampling mechanism, what the sampling mechanism says, that we need to start with least values of dependent variable. So that's why I started from the least value of the dependent variable, right? So it was fitted luckily. Okay, luckily. So that's why the exact line has drawn. Now you see here, second line. Now my slope is changed. Just observe, my dear friends, this one there where this point is intercepting say 10%, this is 5%, right? Now what I did, starting the same point, drawn another line. Now these four, right, these four were well separated, and these two are well separated, but slope changing for a better result. No, so this is intercept unchanged. Here my intercept is unchanged. Y values still remain same. So how would you draw a line through the points? How do you determine which line fits best? You tell me now. Obviously the second one, slope changed one. Why? Because see, this point is intercepting something. So I cannot say that what kind of optimal, what kind of parameters that parameters need to be examined. Might be some kind of parameters will be missing there. right? But if you consider this one, then definitely that it will give optimum result. Yeah. Okay. Yeah. Now, third line. So this is creating more problem. You know that more problem, right? Intercept change now, and slope. See the slope. Here the slope is changed, but here slope is unchanged. And what's the difference? That intercept changed. Now, then again, that we need to find out the difference between the previous intercept and the current intercept. But definitely, the current intercept is creating problems, my dear friends. Where see, it is intercepting all the points. This one, this one, this one, and this one. At least 5%, and this is completely 20%, more than 20%, and this is 15%, and this is 5%, like this. So examining this is really difficult. Now let's see another possibility. Okay, intercept changed, slope changed, both. Intercept is changed and slope is also changed. Now what's the difference? Now the third point is intercepting up to 5%, and it is giving well fit, well curve fit. Okay, now another possibility. Yeah, 4 possibilities. Now then, what I mean to say from this, that I would like to have best fit, which can give the exact modality, so that the computation will go without any hesitation and the accuracy will be predicted properly. So the least square concept says that best fit means difference between actual y values and predicted y values are a minimum, but positive differences of set negative ones, right? So this is calculated in this way. This is the form of square error, right? So this is the second one. This is the first one, that we are performing the square, and finally equalizing the random erroneous value and finding that which one is the best, right? We are checking the possibilities for all in order to take a best fit option. That's it. Right. Now best fit means again difference between, as usual, that I'm not changing, that actual y values and predicted y values are a minimum. Best positive differences of set negative, so square errors. Now here, what is the modality? What's the modality? That least square minimizes the sum of the square differences, right? See, if I'm keep on changing the values of intercepting, that changing that up to the 60 up to 100 based on interval, that if I located the values as pointer wise, then my calculation will go in a drastic way, right? So which requires again resource utilization also. So it may create problems. Yeah. So that's why the least square minimizes the sum of the square differences, like errors. We take the help of least squares, that is SSC. This is the one modality. Now, if you apply the same, then what is the level up to? What up to level means what? The level of errors can be considered? It's up to us. If you feel that, see, I have checked the possibility of 4. No, here, see, starting from this is 1, 2, 3, 4. Only 4 possibilities. So that's why I included 4 errors. 4 errors. That's it. And accordingly, the same has been calculated, and the new values have been predicted with the values. Since the least square is minimizing the random error, right? And after some point, the value will be fixed, and because of that reason, the random error concept is eliminated from the expected output. So y cap is equal to b naught cap as the like this. This is the modality of calculation or inclusion with least square graphical. Now, our ultimate goal comes back. That is that ultimately we supposed to predict the exact output, right? What we do, right? Then that I'm not speaking about the sample slope. So these modality will be changing. As I told you, that beta 1 cap values will be changed, right? And these are the mean, that x bar is the mean and y bar is the mean, and xi, yi, and xi the actual values of inputs. Okay. So my concern is about intercept changing. So the y is changing. Since the y is changing, the y cap will be changing, y bar will be changing, mean will be changing, right? Accordingly, what happens? This value will be changing, so finally beta naught will be calculated. Finally, beta naught will be calculated. So what is the possibility? So until the random error case is verified and optimized in a clear-cut manner, see, the beta value will be given as a exact value like this. So there is an impact, beta naught, right? That's why the intercept value, conditions will be checked properly, and the sample slope that I'm not speaking, this is the normal calculation, fixed calculation, and with this we'll go for the prediction equation, like finally yi cap is equal to b naught cap and b1 max something. This is, as I told you, that I have eliminated the error correction. Why? Because that is limited. Okay, this is the another advantage. So now that how can we derivate? Then I don't think so, like that I don't want to discuss about this one. So this is all about gaming theory like mathematics. Okay, yeah. So yeah, if I discuss about the changing of parametric values of xi, yi, and up to the level of maximization, right? And then up to what level the values can be configured, this is up to us. Then since I have considered 4 stages, so up to the 4 stages, the modality has been tested for randomness errors. And finally, that whatever the error occurs and fixed with that, then sigma xi, sigma means x1 plus x2 plus x3 up to x can be calculated like this yi, like this xi square, like yi square, and like this. So this is the computation. This is fixed. This is fixed, right? So interpretation of coefficients, like my concern is about b1, right? B naught is fine now. Right? B naught is fine now. This is quite fine now. Why? Because so this, from this intercept, the value has been observed, and this is fixed, b naught. Now let me eliminate b naught also. If I eliminate b naught, then in a straightforward way, that I would like to have a straightforward output along with the basic input or number of inputs provided for this independent variable. Now the scenario will be changed. No, why? Because another parameter is included. So this is the coefficient. Now what would be the impact if the coefficient is fixed? Is it fixed? No, I don't think so. Why? Because see, changing slope, changing intercept, and without changing intercept, changing slope, causing some errors, right? So that's why what we do, that this slope will be calculated in a clear-cut manner, that estimated y changes by b1 cap for each 1 unit increases in x. Okay, so if b1 cap is equal to, say, for 2 intercepts, then y is expected to increase by 2 for each 1 unit increase in x. It's a simple example. Nothing here. No need to worry about. What's that? What it says, that I have initially spent 4 lakhs, then I got 2 lakhs profit. After that, for 8 lakhs have been spent, and again 4 lakhs profit. 2 increasing. But after some time, the modality of calculation has been changed. Like while spending 8 lakhs, that I had seen a drastic increase in my profit. Instead of 8 lakhs, it was reached up to 9 lakhs. Now the slope value is creating some problem even. So how can you fix the coefficient values? Like what we do, we take the average of that. That till what time? So if I consider 4, then I'll take the average of that. Even the 4 intercepts gives a same value, that we supposed to take the average. By 4 it will be the same, right? So if b naught cap is equal to 4, then same will be considered, that then average y is expected to be 4 when x is 0. Simple. So in this way, the coefficients can be considered. See, I have placed one example here, that is obstetrics for the medical field, that this birth weight and STL something. So what is the relationship between mother's STL level and birth weight using the following data, say example. Right, say the STL is, say, milligrams for, that is 24 hours 1, then the birth weight grams per 1000 is 1, like 2 is 1, see, 3 is 2, 4 is 2, 5 is 4. See, why it is not unique, like here 1 is 1, 2, why it is not 2, 3, why it is not 3, 4, why it is not 4, 5, why it is not 5. This is due to the randomness errors, my dear friends, right? So in this way, the same that I would like to depict in a pictorial representation, like the birth weight I have considered as the dependent variable, and independent variable is to your level. Okay, see, let me fit. Starting with that, this is the parameter estimation of value. Starting with xi, yi, xi square, yi square, xi, yi. See, the level is increasing each and every time, 15, 10. See, the independent variable is giving the max value as 15, but the dependency found was 10. My God, what's happening here? Even the independent optimality is increasing up to 55, and the dependency is up to 26%. Now, the combination is only 37%. So this is the parametric equation. Now that how it has come, how it has miscalculated like that. I'm not discussing about this part. You just see the last part, my dear friends. Right? So B naught is supposed to calculate, and Y bar is the mean of that, and B1 is the calculation and actual calculation involved, and X bar is the mean of that. So these values are predicted. Then up to two levels, up to two levels, the configuration has been considered. So 2 mean is 2 minus the B1 cap is estimated up to 0.70, and the mean of X bar was found was 3. So see, it has gone to minus region. Would it be considered? See how the solution is creating the problem. So coefficient interpretation solution, if I speak again, that let me apply the concept of slope, that birth weight y is expected to increase by 0.7 units for each 1 unit increase in histriol x. Birth weight y is expected to, that dependent variable is expected to increase by 0.7 units for each 1 unit increase in histriol. Right? What happens? So my intercept is depending upon B naught, and what I did, then I took average, average birth weight, that is what is minus 0.10 units when history level is x is 0. So this is really difficult to explain. You cannot expect then if you say like the baby is going to get a birth with 0 weight, can you assume like this? Right? So the birth weight should always be positive, no? So this is the simple and best example I can put in front of you to show the mathematical simulation for regression. Yeah, so this part that I don't want to discuss much, like that changing the modality of the values, right? And these are the changing values. It means intercepting and parameter estimation for computer output. Like we keep on changing the values based on the previous research, and we are applying common sense. If you speak like that, if you say the same to the mother, but who is going to give the birth for a baby, then she will go in a trance. It should not be so. The medical field will become means we'll see a big failure. So it won't. Right? So see, the value has been updated. Parameter estimate has been updated up to 0.7 at least, and accordingly the error has been observed like 0.63 with minus 0.10. It was observed 0.63 error rate. Right? So it must be so. Intercept will be changing time by time, and accordingly B1 beta naught cap and B1 cap will be changed. So in this way the modality has been observed. Now if you see the challenge, like let me consider the same example, that parameter estimation thinking challenge. Like you have a epidemiologist for the county cooperative, then you gather the following data. Like okay, food 6 4 6 10 12, and milk yield is 3.0 5.5 6.590. What's the relationship between a cow's food intake and milk yield? Yeah, let me frame that one of the food I would like to that. Milk yield is the independent variable, and okay, what it may be, food is the dependent variable. Same concept, no? Same concept, right? Then how can we predict? That lot many challenges, my dear friends. Simple. The story runs in between the dependent and independent variable. Then no need to bother about deterministic consideration, that we need to feel we need to feel or we need to think more about probabilistic situation, where the probabilistic situation involves randomness, like error kind of considerations, right? So same. So the scattergram, that milk yield versus food intake, then yield was dependent variable considered, food is okay independent variable. Yeah. Now the same. This was the configured estimation. Okay, not prediction. Parameter estimation solution, not prediction. Okay, so my estimation is like this. Okay, so estimation should not prediction should not less the estimation. It must be beyond the solution of that particular problem. Like, so these are the yields, means predicted, means estimated based on the parametric values, even after considering lot many problematic situations, right? And the same has been calculated, my dear friends. Same has been calculated like this. Then how can we resolve the coefficient interpretation solution? The same problem, like that the value is fixed, parameter value is fixed here, that milk yield is expected to increase by 0.65%. Okay, LB is the unit, and for each one I'll be increase in food intake X. Okay, and y-intercept, that is B naught cap, sorry, cap came down. Average milk yield Y is expected to be 0.8 LB when food intake X is 0. So this is a fourth different problem, huh? Yeah. So what I mean to say here is that each and every time that you can see the possibility of changing the modality of this one, B naught, B naught cap, B1 cap. So if the parametric estimation is going well each and every time with average randomness calculation, then definitely the B naught cap will provide you the good result. So since it is an independent, it is a constant entity, so it won't create much difference. It won't create much difference. But this one, B1 cap may create much difference in the prediction equation. So I'm speaking about prediction, that I have estimated the possibility based on the parametric values, and you can get the estimation based on the parametric values, but that prediction must be done in an accurate manner so that your suggested or proposed or simulated model would be useful for the society, right? So that whatever the field you choose, that you can apply anywhere, and you can configure your own estimation in terms of mathematical equation by having strong theory assumption. Okay, strong theory assumption, that without having strong theory, then if you go, no, what happens? Then the error randomness will be increased each and every time. Then you'll be involving in calculating the same and checking the possibility of randomness occurrences each and every time. So it will create means extra overhead in your computation, so which is not suggestible, right? So my dear friends, and this is about the regression kind of techniques, right? Yeah, hope you have understood the modality of regression and its importance in various fields. Okay, then please do let me know if you have any specific queries. Yeah, any specific queries from your end? Any specific queries? Hope I have finished within time, I believe, right? And even some disturbances happened, then I try to minimize the concept with suitable examples, I believe. Okay.
Okay, thank you, sir. Thank you for your informative presentation.
Yeah,
And
yeah. Please.
now the session is open for queries. Dear participants, please unmute yourself and ask the question. Now the session is open to queries. Sir, I will read it. Is
Yes,
there
yes.
any
Yes, tools are
tool?
there. Yes, yes, yes. Tools
Is
are
there
there.
any for
Tools are there.
calculating
But see, the
accuracy?
traditional tools, know that these traditional tools won't help you much. Okay, won't help you much in um, optimizing the situations for different fields. Like, say, even if you consider the medical field, and if you'd like to do with, say, eye related issues, the parameters of eye related issues are different as compared to, say, lung cancer type of issues, right? This is the way. What the tool did, you know, that it was deployed with the configured methodology, or yeah, configured mechanism of the algorithm. That's it. So based on your requirement, you're supposed to change the modality of the particular platform. It's a statistical tool. Lot many are there, but it won't give you much accurate results. Why? Because say from data set to data set, if I consider the same, then from data set to data set, the result will not be same. Okay, tools are there. Lot many tools, traditional tools are there. We won't use that. We what we do, no, we train the algorithm especially, and based on the data set formation, we try to check the modality of that algorithm. Right? Why? Because otherwise it will start behaving in its own way. So whatever the parameter you give in terms of different data sets, it will consider the pre-optimized values. Right? So it is not a good practice, I believe. Then you better simulate the same, that even in MATLAB you can do, or MATLAB is the best option for if you like to do with some data sets for a single machine. Right. If you'd like to do with big data kind of thing, then the same can be deployed in the stack of Hadoop. But then in the stack of Hadoop, this algorithm is already deployed. So if you have terabytes of petabytes of data, then the same can be scattered accordingly, and the computation can be done. Okay. So this is the modality. Right. Yeah. Good question. Any other questions?
Yeah, dear participants, still if you have any questions, yes, you can. Okay.
Yeah.
Yeah.
It's okay. If you do
Okay,
not
sir.
have any questions, then fine. Then I'll be
Yeah.
free.
Yeah.
Okay.
Yeah, sir. Thank you so much, sir. Thank you for accepting our invitation to
Yeah.
deliver a talk about regression. Thank you
Okay.
so much, sir. Your session was full of valuable knowledge. Yeah. Thank you so much, sir.
Thank you. Thank you very
Yeah.
much. Okay.
Yes. Now we'll take a break. We'll take a break for 5 minutes. And after that, we'll have the session about logistic regression and its application. This session is by Dr. K. Ailaya, NIT Varangal. So it's a short break. So let us take a short break for 5 minutes. We'll be back soon. Dear participants, welcome back. Now we'll have the session about logistic regression and its application. And this talk is given by Dr. K. Ailaya from NIT Warangal. I would like to invite Dr. K. Ailaya Garu from NIT Warangal. Before starting the session, I would like to introduce our today's session speaker, Ailaya Kaveti Garu. Dr. Ailaya Kaveti Garu is working as an assistant professor, Department of Computer Science and Engineering, National Institute of Technology, Warangal. Ailaya Garu received BTech degree from JNTU Hyderabad 2004 and MTech degree from JNTU Hyderabad 2010. And he received PhD degree from University of Hyderabad in 2016. Ailaya Garu had 25 plus publications, includes in high indexed journals, conferences, and book chapters. Dr. Kaveti Ailaya Garu had 12 years of teaching experience, and he is guiding PhD scholars, research scholars also. Ailaya Garu is a professional member in IEEE, and he is also a senior member. Now, I would like to invite Dr. Ailaya Garu to take over the session. Sir, welcome you, sir. I request
Thank you.
to take over the session, sir.
Yeah, thank you, ma'am.
Yeah, thank you, sir.
Yeah, good morning, all the participants and the my colleagues. Maybe somebody may be registered. Okay. So today's my session is on logistic regression and its applications in real life applications. Yeah, before going to that, we'll have actually today's agenda is first what is regression. So before to regression, actually what is machine learning, then what are the types of machine learning, let's say then what is regression, then what is logistic regression, then what is the difference between linear regression and logistic regression, then the application areas, and we'll have a small projects like how to use logistic regression to solve real life problems using Python. So this is my agenda today, right? So just a minute. Yeah. So first, what is machine learning? I think you have the basic idea about machine learning, but we'll have a glance, a small brief introduction about these things, and we'll proceed with the logistic regression, right? So generally, what is machine learning? Machine learning is a science of making computers to learn and act like humans by feeding data and information without being explicitly programmed, right? So what is this? So we are making the computers to learn and act like humans, right? Suppose suppose we teach the students, suppose our children, right? So this is apple, okay? So we are feeding some information to the children, right? So later on, when they see that object, that apple, they can easily recognize that. So like here we are also training the computer to learn, and so it will act like our human being, right? Yeah. So here, suppose simply here, if you observe with the artificial intelligence, so we are training the system. Okay. So now it will learns and predicts, and based on the feedback, so it also improves. Let's say, so machine learning is a science of making computers learn. Okay. Anyway, this is suppose if you see, this is the system. Suppose it analyzes the past data. Using that past data, using the past data, we are training that system, and suppose if we give some input, it will predict what is that object. So that is the machine learning. Now coming to types of machine learning, we have different types of machine learning here. So that is supervised, unsupervised, and we have reinforcement learning, right? So anyway, we'll today we'll more focus on supervised. Okay. Yeah. So supervised learning is a method used to enable machines to classify or predict objects. See, so here is a method, supervised learning is a method used to enable machines to classify or predict objects, okay, or problems or situations based on the labeled data giving to the machine. Suppose if you see here, we have some label data here. So what is this label data? Suppose here this is a circle, right? So these are circles, this is a triangle, let's say this is a square, right? So now we are giving this data as well as its labels. Suppose see here, this is circle, this is square, this is a triangle, right? So we are now doing training the model, okay, such that in future, suppose if a new data object comes, suppose let's say this is a new data, okay, so now the system has to predict, so what is this object, exact object. See here our system is making prediction that the input is this one, so it is predicting it as square because the model is properly trained. Suppose if this is the object, then it is predicting it as circle, okay. So this is supervised learning. So what is meant by supervised learning? Based on the label data, okay. So we are training the model such that, so it will predict for the test data, it will make the predictions, right? Taking the unsupervised learning into the learning, suppose here simply we'll give some unlabeled data. So based on this unlabeled data, so this will train this model such that it will classify those models into different categories. Okay. So if you see here, these are in one category, these are in one category, these are in one category, right? So this is actually unsupervised learning. Coming to the differences between supervised and unsupervised. See, so in supervised we will have the label data and there is a feedback. Okay, so suppose if the accuracy is less, so we have to give the output of this model to as an input. So it is given as a feedback. So based on that one, based on the predictions, it will be trained again, and so it will predict the output. But if you see the unsupervised, there is no label data, there is no feedback, and it will find the hidden structures in the data. So we'll give some data, so it has to classify, right? So generally, this supervised learning, we can call it as that is used for classification. Okay, so classification of the label data. Suppose whereas unsupervised is used for clustering, right? Yeah. Now, anyway, types of supervised learning. So there are two types of supervised learning algorithms are there: classification and regression. Right. Now, what is meant by classification? Yeah, classification is concerned with building models that separate data into distinct classes, distinct groups. Okay, so that this is classifying the object into different objects into different classes. So whereas the regression, see, the regression is the regression models are based on the previous input data, so they will predict the continuous output values. Okay, we'll see the examples for each, no problem. So for classification, we have different algorithms like decision tree, support vector machines, logistic regression, whatever today is our session, is also a classification algorithm. Right. Now for regression, we have the algorithms like linear regression, polynomial regression. Okay. Right. Now, yeah, we'll see some examples, real-time examples, where we'll use classification and where we'll use regression. Right. So now, do you want to predict a category? What is that? So do you want to predict a category? What is meant by that? This is a classification problem, because so what is that animal, or whether that person is that human is a boy or girl, or you can have many examples like whether he will win or lose, that is true or false. So in that type of situation, we'll use classification technique. Okay. Suppose now suppose if you see here, whether the stock price will increase or decrease. Suppose tomorrow, whether the stock price will increase or decrease. So this is the categorical values. Okay, this is the discrete values. So whether increase or decrease, true or false. Okay, so this type of thing is called classification. Suppose now if you see, do you want to predict a quantity? This is regression. So let's say, suppose, let's say I will take an example. Suppose every year our organizations, our institutes will give hikes to the faculty, right? Based on their API score, based on their rating, means their performance, right? So let's say now I'll differentiate what is classification and what is regression with that example, faculty appraisals, right? Whether a faculty will get hike or not, that is classification, right? Whether a means sorry, whether a this one whether a faculty will get, whether a faculty will get hike or not, either promotion will get a promotion or not. But what is now regression? Regression is that predicting his salary based on his API score. So promotion is different, whether he will get the promotion or not, that is classification problem. Whereas what may be his salary, his or her salary, that is the regression problem. Okay, so based on his what is that API score, suppose if the API score increases, automatically the salary will be increases, but that is regression problem. But what is classification here? Whether he will get promotion or not, okay, or so whether he will get hike or not, okay, this is the classification. Right, now see here, we'll have more examples here. Suppose supervised learning, we have classification here. So supervised learning is of two types, right? Classification and regression, right? So first we'll see classification. Let's say we are training the model such that this is some images of girl, images of boy. This is the past data. We are training this model using this data. Now, if a new data comes, whether she is a girl or this object is a boy's picture, boy's pic. Okay, so suppose if we give this one, so what it is predicting, whether it is a girl, whether she is a girl or boy, girl, right? Because we trained the model తగ్గి ఫోన్ చెప్తాను మళ్ళీ పెట్టుకోండి. Yeah, yeah, it's fine, sir. Now it is again connected. Right. Suppose, let's say, so now it is audible, right, sir?
Yes, sir. Yes, sir. Carry on.
It's fine. Right. So with this regression, if you see, this is a it means this is a linearly the output y will be linearly increases with the x. Okay. Suppose now if you want to predict something, suppose the size of the house is this much. Now what may be the salary? What may be the salary? So in that type of situation, okay, we'll use regression. Suppose let's say this is the size of the house. Now the price may be 12 lakhs or something between 2 to 8 lakhs something. Okay. So like that the regression will be works. Right? See, this is an example I taken for regression. Now, a regression actually, what is regression? A form of statistical modeling that attempts to evaluate the relationship between one variable that is called as dependent variable and one or more other variables that is termed as independent variables. So, it is a form of predicting one variable from another, right? So generally, what is regression? Regression is a predictive modeling technique. It estimates the relationship between a dependent variable that is called a target variable. Like here in the case of our previous example, the price of the house, that is a dependent variable. Now, what is the independent variable? That is the size of the house. Okay, we'll call this dependent variable as the target variable and the independent variable as the predictor. Yeah, so dependent variable is the one which we want to predict. Suppose let's say I want to know what will be the sales on, suppose let's say 20th of this month of a particular product. Okay, so generally the sales, suppose what will be the sales of a particular product on 20th of this month. So the sales depends on what factors actually. Generally, the sales is the dependent variable on different parameters. Suppose let's say the number of products sold till date, or the season, the availability of the product, or the product quality. Okay, these are the different parameters. Suppose if the product quality is good, we can estimate. Okay. Suppose this is a season, suppose seasonal, based on season also we will have the sales, right? So based on these dependent variables, so that is the season, the availability of the product quality, different things plays an important role in predicting the dependent variable, the target variable, that is the sales here, right? Right. Now we'll have suppose for that linear regression, because why I am explaining this linear regression is that the logistic regression is actually a classification problem, but the concept we'll use in logistic regression is based on linear regression. Okay, so actually logistic regression is for classification, linear regression is for regression, but the logistic regression will use the concept of this linear regression to make this formula. Actually, what the formula we'll use in logistic regression will be we'll get it from the linear regression. So that's why I'm explaining this linear regression. Yeah, suppose if you see here this curve is a linear curve. We know that this curve, what is the equation for this curve? Actually, y equal to mx plus c, right? So y is the dependent variable and x is the independent variable. So that y will depends on this x, where this m is the slope of this curve, slope of this line, right? And c is the y-intercept, right? So y equal to mx plus c, right? So this is the actual the equation Suppose let's say if there are multiple independent variables, like our previous example what I taken, the sales of a product, the sales is the predictor. We need to predict the sales based on the independent parameters. What are the independent parameters there? The quality, the availability, the season, etc, etc, etc. Let's say x1 is the quality, x2 is the availability, xn is the season, let us use. Okay, so like that there exists multiple parameters. So if the the dependent variable, that the predictor is dependent on multiple variables. So in this situation where this b0 is the this one slope here, b1, b2, b3, bn are the intercepts, right? And x1, x2, xn are the this independent variables. So the equation, we can regression equation, we can model it as y equal to beta naught, that is you can call it as m0, sorry, right, c0, like m1 x1, m2 x2, m3 x3, like that, right? Now given a set of points, we wish to find a linear function that goes through these points. Now what we need to predict? Let's say that suppose using that linear curve, let's say these are the sales and this is the independent variables. Let's say these are the sales today, and these are the sales maybe these are the sales yesterday, these are the sales today, and we can predict the sales tomorrow using the linear regression curve. The sales may be somewhere here, right? So this is a curve we can use for linear regression. So now to find out to predict the particular sales on particular day, we can use that curve to predict the sales, right? But the exact alignment may not, that is the predictor, but the actual sales may be different. So that is called the error, right? So I think you have some idea about linear regression. Suppose if you see, this is a predicted line actually, but these are the actual sales. Let's say these are the actual sales on, suppose let's say 5th of this month, 10th of this month, 15th of this month, 20th of this month. Now we want to predict the sales on 25th. Let us, you might take an example. This is the sales on 5th. This is the sales on 8th. This is the sales on 10th. This is the sales on some like that. Now, if I want to predict the sales on the 27th of this month, so it may be like this, but the actual sales may be different. So that difference, the difference is called the error. So we can use mean square error or something to fit this correct the model. Right. Now coming to the logistic regression. Now what is this logistic regression, and why we have to use this logistic regression? Yeah. So the linear regression, whatever we discussed as of now, the predictor, the dependent variable is in the range from minus infinity to plus infinity, because if you see, if we decrease the size of the house further, so it will go like this, right? So if we increase the size of the house, so it will go like this, right? So this is a continuous, but whereas coming to logistic regression, logistic regression produces results in a binary format, so which is used to predict the outcomes of a categorical dependent variable. So the outcome should be either 0 or 1, right? Such as true or false. So this is a classification problem, what I said, right? is like that. No audio. Divyaraj. Yeah, is it audible, sir, now?
Yes, sir. Please continue, sir.
Okay. Right. Now, this is the actually the linear regression curve. But we know that the linear regression curve is continuous. But logistic regression, suppose let's say we need to have either he may suppose here an example taken is, suppose a student suppose the marks of a student will depends on the number of hours he or she studied. Suppose if we do more means if we do more work means hard work, then he will get more marks. If we spend more hours on reading books, he will get more marks. Like suppose the increase of number of hours will increase the marks. This is a linear
Sir,
regression curve. Yeah.
sir, sorry to disturb you. Can you please share your screen, sir?
Oh, again, sorry.
Yeah, yes, sir.
Every time, right. It's okay. Is it okay, ma'am, now?
Yes, sir.
Okay, it's fine. Okay, suppose here if you see with the linear regression, this is a continuous process. So if a student spend more hours on reading, so he'll get more marks. But what is logistic regression? We need to find out whether he will pass or fail, right? So either he will pass or he will fail, right? So that is either 0 or 1. Okay. So in this situation, now how to use this linear regression equation to make it as to use it for logistic regression, right? So this linear regression curve, it cannot divide the outcome into categories, right? So it is continuous, right? Now, right. So in this situation, we'll use the logistic regression. So to make this linear curve into a logistic regression curve means to use it as for logistic regression, we'll use a sigmoid function on this linear regression curve, so that it will have if you see here, we'll get the sigmoid curve. So actually this is called a sigmoid function. So this sigmoid function, actually the derivation, if you want, I'll explain with this one. What is that? Actually here I think we may not have this pen option, right, ma'am? Do you have this pen option, madam, to means write something? I don't think so. Right. Okay. So now if you see this we are just clipping this curve such that now we have 3 lines. One line that is means that is coincide with 0 value, and one value that is coincide with 1 value, and this is just looking like an S curve, or we can call it as sigmoid curve. So we know that I'll explain means of 2 minutes how we can get this sigmoid curve, and means how we are means using linear regression to means derive the equation of logistic regression, right? We know that the range of this curve is from minus infinity to plus infinity, right? Minus infinity to plus infinity. Okay, so what is the equation of this curve actually? So y equal to mx plus c. So we can have y equal to m1 x1 plus m2 x2 plus m3 x3 plus like that plus c, right? Now the range of this one is minus infinity to plus infinity. Now let us try to reduce the logistic regression equation from this straight line equation. But what is the range here? Even though we means if we derive this one, the range is 0 to 1. But we have to, even though this is 0 to 1, now we have to transform this one to get the logistic regression curve also from minus infinity to plus infinity. So for that we have a odds ratio that is called odds of p by, that is 1 minus p, that is called probability of win by probability of not win. Okay, probability of lose. Okay, so in that situation, so we'll get actually this either the range is from 0 to infinity. 0 to infinity. So if we perform log it over that odds ratio, that is p, okay, that p will get the range from minus infinity to plus infinity, that is infinity. So which is equivalent to this minus infinity to plus infinity means what? Again, this is a linear curve, linear straight line, right? So like that, using that odds ratio, because actually this thing actually don't worry about this formula. In Python you have you just need to call this formula. We will have the direct formula, that logistic regression. Okay, so everything automatically it will do the thing at the conversion of this straight line to sigmoid curve, everything it will do. So I don't want to means you don't worry about this, and no need to remember these mathematical formulas and all those things. Suppose as a means we are not mathematicians, but anyway, as a computer science means faculty, we need to remember, we need to know these formulas little bit, right? So from odds ratio, what is odds ratio? Odds ratio is the probability of win by probability of lose. So if we suppose if we apply logarithmic over that one, we'll get the range from minus infinity to infinity. So just it looks like the linear regression. So that's why this logistic regression is actually called the classification, but means the regression is different, right? But the name given here is regression, but the logistic regression we are calling it as, we are using it for classification, right? But the underlying principle behind this one is linear regression, right? Now anyway, I'll stop with this presentation. Now we'll have some demo, means in real life how we can use this logistic regression. Suppose let's say for prediction of the weather tomorrow, what prediction of the weather, suppose let's say whether it may be, there may be rain or not, some real life examples, right? So there may be means there may be sunny or not, there may be cloudy or not, there may be snow or not, means either true or false. But how linear regression we can use? We can predict the tomorrow's temperature, that is continuous, right? That is continuous. But with logistic regression, we are predicting whether there may be a rain or not tomorrow, right? Next, we'll have suppose here I will take two examples for means this demo. I think you have this anaconda or something similar. Right. So today I'll explore these two projects. Like suppose mostly in machine learning there are some data sets are there in means in online, in website, in web we have different data sets. Suppose here I taken Titanic data set, and one more data set is SUV cars data set. So first suppose we know that the Titanic data set. What is the Titanic data set? First, we'll have a brief discussion about Titanic. I think most of us saw this movie Titanic, right? So the Titanic was a British passenger liner that sank in the North Atlantic Ocean after colliding with an iceberg, right? While traveling from Southampton to New York, right? There were more, I think, more than 2,000 passengers, and 1,500 people died. So this is a big disaster, right? And the next data set. So now, based on this data set, anyway, we have the data. What is the data? So what are the parameters? Actually, what are the parameters involved in what are the parameters involved, and how many people survived, and how many people how many people survived. So we'll see this by using that logistic regression. We'll see these factors. So, which are more likely affected to survive the even though the sinking of the Titanic. Okay. The next one we'll take is data analysis on the this SUV cars. Suppose, let's say we have a car company has released a new SUV in the market. So suppose, let's say, using the previous data, now we need to analyze what may be we need to predict what may be the sales of this car. Okay. Suppose, let's say, using the previous data, like sales of their previous SUVs, their company's SUVs, and we want to predict the categories of people who might be interested in buying these. So what factors made people more interested in buying SUV? Yeah, right. So I'm with the Python. Now we'll see how we can use logistic regression to predict these things. Right. Yeah, this is my Jupyter notebook. I think 12:15. We have 45 minutes left. Okay, we'll see how we can implement logistic regression for this particular problem. Right, just I'm naming it as what is this? Titanic. Right. So first we need to import the libraries, right? Import libraries. Right. So import pandas as PD. So we know that Panda is for this data analysis part. And import NumPy as NP. So this is for performing some scientific calculations, right? NumPy library. Then import Seaborn as SNS. So this is for statistical plotting, right? The Seaborn and MATLAB lib for plotting purpose, means for plotting the graphs, etc. Next, this percentage. Sorry, MATLAB. I'm comfortable with MATLAB actually. So matplotlib inline. So this is to generate this graphs within this anaconda, means within this one. To run this one, actually we have multiple options. I know all of you know this execution of this Python code. So we can use this run option, or you can simply use shift enter, right? So this is importing libraries. Now we'll see the data first. This Titanic dataset. Titanic dataset. See here we have these are the different fields who traveled in the this Titanic. So this is the passenger ID and who survived. This is the passenger ID. Let's say I think 891 passengers are there. Passengers details are there here. Even though there are 2000, more than 2000 people are there, 2200 people are there in the Titanic, only the data is available for 891 people with us now. So this is a survived column, whether that particular passenger survived or not. 0 indicates no, 1 indicates survived, right? So passenger class, these are the different fields actually. Passenger class, so third class, first class, we have here 3 classes. Third class, first class, let's say sleeper, like that. Third class, first class, and second class. So this is the name of the passenger. This is a sex, either the gender, either male or female, and their age. Here you can observe some null values also here in the age column. I think it is visible, right? Now this is the information about sibling and spouse, and this is the information about parents and children, whether any siblings or spouse are traveled along with that particular person. This is the parent and the children information. This is their ticket number. This is the fare they incurred, and this is the cabin, and this is their so means embarked place, means from where they started their journey. Okay, this is Southampton, something. This is Queensland, and one more C is there, Christchura, something is there. Okay, these are the cities names, right? So anyway, this is the data of the Titanic, Titanic data set. Now we will see, okay, sorry. Right, now we'll read this data set for analysis. So PD is the instance of pandas library, so which is for data analysis. PD read underscore CSV. This is a CSV file. So the name of the data set is Titanic underscore train dot CSV. So some mistake. Not found error. Yeah, sorry. So actually my file is in downloads, right? So I'll copy that link first. Okay. So now I read this Titanic data into this train variable. Now we'll see the data a little bit. Train dot head. It will show us the data. Suppose let's say some 5 instances. You can see here passenger. This is the index passenger ID 12345. Survived or not? Passenger class, name, sex, age, whether siblings, and this information is there, right? So now we will see what is that information means. How many passengers are there? how many passengers are there, and what are the different. You can observe here there are total 12 columns, 12 fields, means 12 parameters are there, right? So these are passenger ID up to embarked, and so they are, the floating type or the means the fields. The data types are here. If you see, integer types, object type, and floating types are there. So now we'll see how many passengers are there. See, count here. The 891 passengers are there. Their mean this one mean value. These things are there. This is the 891 passengers, and their this age given for age only 714 parameters are there. So anyway, this is some information about this data. Now we'll analyze this data. Right. So for analyzing and for these graphs, scientific statistical graphs. So we'll use this Seaborn. So the instance of Seaborn is SNS dot count plot. So the data is from train. Just observe here. If you see how many of them are survived, approximately 300. So the total count, we are getting this count plot here. So from this data, so this is the analysis actually we are doing here. So more than 300 are survived and more than 500 are not among this 891 passengers. Right. Now we'll see the means how many males are survived and how many females are survived. Suppose x equal survived and hue equal to here. So this blue, this label indicates this male, and this orange indicates female. If you see, this one indicates survived and 0 indicates not. So if you see, the female are survived here, means compared to this male, right? Among this 891, so here 100 males are survived, and more than 200 females are survived. Okay. So now we'll see based on passenger class. Suppose the richer people will generally in the first class, right? Passenger class, P class. See here, the people who are in this is blue indicates passenger class 1, orange 2, and the green indicates passenger class 3. These are survived people, these are not, right? So if you see more than the passenger class 3, means most of the people are not survived. Okay, they are means they are poor people maybe. Okay, so if you observe here, the passenger class 1 people are survived more compared to the passenger class 2 and passenger class 3. But who died actually, mostly the people who from the passenger class 3 are not survived. Now we'll see based on this age. based on how age affected means based on age we'll see whether means the survival rate. See here, mostly from 20 to 40 years, 20 to 40 years people survived more compared to the children as well as elders. Okay, so this is a histogram. Now based on fair again means what? Fair again based on class, right? We'll explore different parameters based on fair incurred. See again here, this what it is showing actually. So based on yeah, fair in the range from this is histoplot. Actually, if you observe this 0 to what is this? I think 50. No, this is something wrong. Fair indicates here their incurred cost, right? Okay, we'll see this one later. Now, anyway, these are some analysis. Suppose if you observe based on the age, the middle-aged people are survived more, and if you see here the low class people means passenger based on passenger class, so the survival rate is there, and here based on sex means that gender also the survival rate is depends on, and based on yeah, so these are the different parameters we explored. But here, if you see here, this passenger ID is not at all important because this is simply for identification, and this name is also not important. The sex, age, and ticket is also not important. This fare actually depends on the passenger class anyway, and this cabin actually cabin. We'll see this cabin is having lot of null values, NAN and NAN. Okay, this embarked also their starting place from where they started, right? Okay, these are the different fields we explored. Now, if you see, actually, if you observe here in this one, there are a lot of in the cabin field we have a lot of null values, not a null. This is a lot of null values here, right? Now to get more accuracy, actually we need to fill that null values with some dummy values, right? So how to do that? So now we'll see how many null values are there. See here, is null. Suppose passenger ID, if this is false, that is not a null. So these are all false. But if you see this cabin, this is true. Is null true means that is a null value. So is null true. These are all means in cabin, this particular thing we have a lot of null values. So actually this will affect the accuracy of the system. So we need to fill these null values with some dummy values. Okay, so how to do that? We'll see now. So how many null values are there? First, we'll see in each case. Here in age field we have 177. Passenger ID there are no null values. Survived nothing. But in age field we have 177. And cabin we have 687 and embarked 2 out of 881. So cabin field is filled with a lot of null values, and age field, if you observe, this is almost 25% of 900, 891, 200. So this is 20% approximately. Okay. Now we'll see how we can we'll see this one using a box plot. Why I'm exploring this is to familiar with the different analysis. So x equal to P class data equal to train. See here with age. So these many here the null values. This is the mean actually. Here this is also based on passenger class. Based on passenger class, this is based on sorry. So what I am actually trying to do is yeah, based on the passenger class, I want to see the average ages of the these passengers. Okay, in passenger one, mostly this the age is between 30 to 50. In passenger class two, the ages are from 30 to 40 approximately. This is the actually this is the mean of these passenger ages. So anyway, now we saw this one. This is not at all important here. Actually, I need to do this one before this step, before this cleaning. Right. Now, if you see this cabin field is having most of the nulls. So in some times, if the most of the null values are there, we can delete that actually. So to delete that one, just use this command delete from train the column cabin. This is not at all important. Or you can fill with some other values by taking the mean of all these things. Now just observe train dot head 5 or 6, some 6 values. Now this cabin field is no more. See, just observe this cabin field here after fare and in between fare and embarked. So I removed that cabin field, and that is not at all important actually, because there are most of them are null values. Now so now we'll fill this. Suppose in this age field also, I think we have 177 null values, right? So now we'll fill these values with some dummy values, or we can replace them with we'll drop those null values. Drop not a null in place equal to true. Now just see this heat map, SMS dot heat map. How many null? Is there any null values? Dot is null, comma y tick labels equal to false. Some color coding I am giving. CB false. Map equal to, this is for color coding. Yeah. Most recent call lost. So what happened? Okay, we'll see this first. Right. Yeah. Now I think it is audible, right?
Yes, sir.
Okay.
Audible, sir.
Right. So now, if you see this, if you observe here, this sex means this gender is having male as well as female, right? So if you observe here,
Sir,
this
can
is
you
the,
please share your screen, sir?
sorry. Okay. So if you see here, now this particular this variable consists of female as well as male. So this is for female. If this is not female, this is male. Just observe this one. So if this is female, this is not male, right? Female, not male. Female, not male. Not female, male, right? So instead of having this female and male, so we need to have only one. Suppose let's say if we drop this female, this first column, if we drop this first column, then suppose if that particular passenger is equal to 1, then that is male. If it is 0, that is female, right? If that is 0, that is female. Suppose in this case this is male, right? So we can drop this first column, right? So to drop that one, simply just use drop the first one. So train of sex, comma, drop underscore first equal to true. Now just see this. Only one column will be there. See here the difference. Only male column will be there for this particular index, passenger ID. Okay, whether he is male. So we are converting this string into categorical values. Okay, so whether this is 1 or 0, right? So likewise, if you see, we need to we will have for passenger class also, for passenger class as well as this embarked, right? So for passenger class, how many values are there here? 3, 1, 2, 3, right? So for embarked also here we have S, C, and one more Q, right? So we need to convert that one into a discrete value, right? That is either means we need to drop some of the fields. First we'll see with the embarked. PD dot get underscore dummies of from embarked. See this now. Now embark dot HD head. Now we'll see. So how many? See here, 3 columns are there for this embarked, right? So C, if this is C, if not C, not Q, then it is Southampton, right? If that particular person is not started from C or Q, then he will start from Southampton, right? Suppose if he starts from 1, means suppose Christchurch something is there, he is not from Q and S, right? So the journey place, the starting place is from only one, the starting point is from only one place, right? So there is no need of, suppose we can drop one of the column here also. Suppose let's say if this is not and this is not, then he is from Southampton, right? Suppose if this is okay, then we can remove these two. Okay, so that's why we can drop this one of the column here. Will describe this one, comma, drop underscore first equal to true. Yes, no. Right. Now see the embark dot head. Just see now. See, he is not from Q. He is from S. He is not from Q. He is not from S. Means he is from C, right? So he is not from Q. He is from S. So he is not from Q. He is from S. So like that, two fields are sufficient here. So we can drop the first one. So likewise, we can also do for this P class. Yeah, I'll copy this. I'll no need to show that. Actually, P class we have 3 classes, right? 1, 2, 3. Now I'll show you only 3 classes will be there. Only 2 classes will be there. PCL equal to PD dot get dummies, get underscore dummy train, that is from P class. Yeah. PCL underscore dot head. So now just see here the class of the passenger ID 0. Let's say The passenger ID of this one is, sorry, the P passenger class is third class, right? This is 3 equal to 1 means he is from third class. Suppose for passenger ID 1, passenger 1, so he doesn't belong to class 2 or class 3, means he is from class 1. So that is, this information is sufficient, right? So we are cleaning, so this with this we cleaned the data. Now anyway, now we need to add these this newly created these things, means after cleaning we need to add this one to this particular data set, and we need to remove now the sex field and this I think embarked field and P class field, right? And here for computational purpose, this name is not important, this passenger ID is not important. You know that this passenger ID means there is no role of passenger ID in the means this prediction, right? And name also. Next, this age is important. This ticket is also not at all important. So we'll drop all these. So to drop this one, we'll have this command. First, we'll append those things. Train equal to pd dot concat of. So what we means we remove the dummy values for what? Sex as well as embark and P class. For the data set train, sex, we need to add sex and embark, and the last one is PCL, P class. Right. Axis equal to 1. Right. Now, yeah. Now just see the train dot head, means the train data, this original data. See here now, we added this, what is this? Only male class, that is a sex, and with sex what we have now, only male class, right? We remove that female class, sorry, female field, right? And this embarked place, we removed that C, right? From the passenger class, we removed 1, right? Now from this complete thing, now we'll remove the sex, name, embarked. Sex is no more important, right? Because we added here, and the name is not important, passenger ID is not important, ticket is not important, this embarked is not important. Just drop that. Train dot drop of sex comma. Next, what is the passenger ID? Next, P class, because they are no more important, right? Next, name, passenger ID, name. Next, sex is over, age, ticket, then okay, that's it. We'll see. Right, in place, true. In place equal to true, comma, axis equal to 1. Right. Yeah, just a minute. We can use double columns or right. Now just see the data. Train dot head. See here. Now we'll have only these fields, which are Yeah, embarked. We need to remove embarked also. Yeah, train dot drop. Yeah, I will write here itself. Or okay, Control C, because this is again a string. So this embarked we added here, right? Q and S. We removed C. Right. Embarked in case. Okay, that's true equals. Okay, okay. Right. Now just see the train dot head means the fields remained. Here index is there, survived or not, age is there, the siblings and the spouse information, this parents and children information, fare, whether male or female, and starting place, and this is the passenger class, right? Now using this we can now we'll do the training and testing. Anyway, yesterday I did this experiment, so I'll show you because of time. So I'll show you that part now. Yeah, Titanic. This is today's. Yeah. Yeah, just see this. Yeah, actually these steps I forgot to specify this heat map, because actually this step is showing the null values. So that's what there is a, yeah, these are the actually null values. In if you observe, these yellow line shows the with heat map, just we analyzed this. So this yellow line shows the missing values. So here also with age we have 177, with cabin we have almost something, right, which how much, somewhat okay, I think 20%, right? Yeah, latter these are the different things we discussed. Then this is the data cleaning part, right? 682 cabin, right? So this is the plot again I used here. Now if you see, after cleaning, after dropping the null values, so this particular the heat map shows there are no null values. Yeah, now we can see the null values here. Train dot is null dot sum. So whether any null values are there, so no null values here, because from the age we removed that, and that complete what is that, what is which one we dropped here, cabin, right? So there is no cabin at all here field, right? Next these dummy fields we removed. Then yeah, now training the data. Just I will show you in 2 minutes. See here, what is the predicted variable actually, survived or not, right? So first from the data, I'm taking that one to the x variable. Okay, train dot drop, and that is assigned to x. Okay, so survived, and y equal to train survived. Okay, so removing that survived, the remaining data. What is the remaining data? Age, sibling, this information, this field, the age, sibling, SP, patch, fair, male, QS, 2, 3 are into the X, and only the survived. This is the Y variable we need to predict, right? So this is survived, we need to predict. Then here we are splitting the data into training and testing. Okay, so based on here these are the parameters, X train and X test. X train, Y train are the parameters of training, and X test and Y test are the parameters of testing. Now this test size means we need to divide the given data set into two parts, training data set and testing data set. So testing data set is 0.3, means the training data set is 0.7. Okay, so means this is 70% and this is 30% of the data is used for testing, and random state equal to 1. So random state equal to 1 means what? For the different trials, we'll get different outputs. means it will split the data into different training sets and different testing sets. If this is 0, then always the training set and testing set are, that is, there is no random, means a fixed training and testing set will be there each for each run. Now this is importing the logistic regression function, what I said at the time of explaining theory. So this function itself will do the this sigmoid, calculate the sigmoid function and convert that one into means continuous to discrete everything. Next, I'm creating an instance of logistic regression LG. Then I'm fitting this model, fitting this training data set to the model. So LG dot fit X train and Y train. Now this is the output of that. These are the different parameters. Now I'm predicting this using the test data set. So predictions equal to LG dot predict on using test data set. Right, now this is the classification report from sklearn.metrics import classification underscore report. So here this is the classification report. If I print this one, print classification report, y test is the what y test is what? It is the predicted. Sorry, that is the original, and this is the predicted. So from that, this will give us the precision and recall. This is the pressure and recall values, and this is F1 score. I think you know all of you this, right? Now from this I am deriving this confusion matrix. So the confusion matrix on this actual values and the predicted values. Okay, so these are the confusion matrix. You know what is this 105 and 21. This is these are the 4 values. So this is true positive, true negative, false positive, and false negative, right? So what it indicates actually, this means this confusion matrix we can use to generate the accuracy, right? So what is this 105 actually? This is true negatives. What is meant by true negative? I think you know this confusion matrix, right? So from this, this is true negative, this is false positive, this is false negative, true negative, false positive, and true positive, right? So to get this accuracy, we need to take this true negative and true positive, addition of this true negative and true positive by total, right? So suppose if we do that, means we can use the equation like from directly we can get that accuracy. sklearn dot metrics import accuracy underscore score, accuracy underscore score.
Yeah, due to power issue at the speaker side end, we'll just wait for a few minutes, 1 or 2 minutes. Yeah, almost the content is over. Sir want to present 1 or 2 slides. So we'll just wait for a few minutes, then we'll end the session. Meanwhile, all the participants, I'm requesting you to fill the attendance and feedback form. Link is already shared. So link will be shared only in Google Meet and YouTube. In WhatsApp
Yes.
groups, we are not going to share the links. Yeah, sir is there. Sir, yeah, continue, sir.
So I think it is visible, right, sir?
Yes, sir, visible, sir.
Yeah. So now accuracy underscore score. Put accuracy underscore score. Then there is a mistake. Is that import? Oh, sorry. Here there is not right. Right now, this accuracy score of Y test and predictions. This is our accuracy. Suppose if you want in percentage, so we can put it as into 100. So this is 0.785 means 78.5 is the accuracy percentage of this particular model, right? So to improve this accuracy, means to improve this accuracy, we can do means a lot of these things. Means suppose here we filled these. Actually, we removed the what is this null values, but you can use other techniques like you can place the mean values or you can have the standard deviation kind of things, and in place of null values you can put them and you can train with more data, okay, so that you can increase the this one, what is this accuracy of this logistic regression model, right? So anyway, this is about this for this Titanic data set. Actually we'll have one more data set, that is whether a person the sales of a SUV car, okay, anyway that is not we cannot cover now because the time is 17 now, okay. Yeah, please if you have any doubts please ask me. Yeah, please, any doubts?
Yeah, dear participants, now it is open to have any queries.
Sir, after converting P class into get dummies, I think value of class is over. Passenger class or what? Yeah, it is over, but we need to remove that complete class, right? What is that? P class is still there. Means we just we removed the dummies. Okay, but we appended at the end. But actual original field is there, right? So we need to remove that. According to data set one class get higher priority. Yeah, that's what. So generally this one we'll use this new bias, this logistic regression, this new bias also for
Yeah, I think due to some problem again, sir is disconnected from this meeting. Yeah, Srinu sir is giving answer for whatever the questions you have posted in the chat window. You please go through that. Yeah, that's about today's session, logistic regression and its application. Thank you so much, Dr. Kavit Ailaya Garu, for accepting our invitation and delivering this practical session about all the regression techniques. Thank you so much, sir, for sharing your knowledge with us. Dear participants, now let us take a break for lunch. So we'll be back at 2 o'clock. So afternoon, we have the session on deep learning convolution neural networks by Dr. G. Madhu, VNR VJIT. So we'll be back at 2 p.m. So now, Srinivasrao sir, you can go with, yeah.
There are different ways of filling the data for categorical data. Like we can give the mean mode value for existing. That is one procedure. Second procedure is predicting the missing value is second one. And third one is following the unique category. If you have some missed data in the given data set or available data set, we can use unique categorical data and experiment with the data what we have taken based on consideration, and do it for our model and see the performance. Based on the performance we obtained, we have the option to moderate the model. Here I am attaching the link in which different ways of providing the missed value is the URL I am giving here, that helps you to get the knowledge about how to get the missed data. Still, if you have any queries, you can chat it, or you can unmute yourself, you can ask me.
Yeah, thank you for your clarification, sir. Thank you. So still, if you have any queries, you can post it in the chat window. Okay, so then we'll be back at 2 p.m. Thank you all for your active participation for this session. Thank you. అయ్యో ఇది వస్తుంది కదా సరే బ్రేక్ ఆపేస్తాం. Good afternoon to all the participants. Welcome back to the session. So today afternoon we have the session about neural networks for image classification by Dr. Sanjeev Kumar from IIT Roorkee. It is our honor to invite you, sir, to this session. Welcome you, sir. So before hand over the session to Dr. Sanjeev, I would like to give brief introduction about Dr. Sanjeev. Dr. Sanjeev Kumar is now working as Associate Professor, Department of Mathematics, IIT Roorkee. Dr. Sanjeev received BSc from CCS University, Mldlt, MSc from IIT Roorkee, PhD from IIT Roorkee. His PhD thesis titled Reconstruction of 3D Objects from 2D Views, Simulation, Applications, and Error Analysis. Dr. Sanjeev Kumar has the work experience as postdoctoral fellow at University of Udine, Italy. And he worked as assistant professor at IIT Roorkee and working as associate professor at IIT Roorkee. Dr. Sanjeev Kumar has the awards as CSIR Research Fellow at CSIR and MIUR Postdoctoral Fellowship at MIUR Italy, and he received Outstanding Teachers Award from IIT Roorkee. Dr. Sanjeev Kumar has 18 plus more publications in various national and international journals. And he received the grants from various funding agencies like ISRO, DST, NIC, SERP, etc. And Dr. Sanjeev Kumar has book chapters like Stereo Vision in a Network of Cooperative Cameras, Springer, an optimally robust watermarking algorithm for stereo image coding, Springer, multi-resolution depth map estimation in PTZ camera network. Dr. Sanjay Kumar, right now he is guiding 7 PhD research scholars. Now, I would like to request Dr. Sanjay Kumar sir to take over the session. Sir.
Yeah, a very good afternoon to all of you. I hope I am audible.
Yes,
Sir, you are
yes,
audible,
sir. Yes, sir, you are audible.
Okay, thank you. So, very good afternoon to all of you, and thank you, Professor FD, for introducing me. And
Thank you.
I hope you can see my PPT
Yes, sir.
presentation.
Yeah.
Okay, thank you.
Sir, can you please keep the slides in full more screen, sir?
Yeah,
Slideshow.
I am doing. So let me start this talk, and in this talk I will give a brief introduction about perceptron model and then artificial neural network, basically multi-layer perceptron. I will also give a glimpse that how we can implement these two models using Python. So first, when in the beginning of the development of neural network, the first model which came, that was the perceptron model. So it was invented by Frank Rosenblatt at the Cornell Aeronautical Laboratory in late 50s. And it was he was aiming to have just a mimicry of human brain, means how we can simulate the human brain model to learn so that machine can learn. When we talk about human brain, so we know that a human brain is having billions of neurons, and those neurons are connected by synapses, and through those synapses we pass the information. That is, information are transmitted from one neuron to another neuron. So if you see here, I have put a small figure about a cell body, dendrites, and then this is a model of neuron. Now, this is basically from the human brain. But when we come to simulation model of it, to make a computational model, a perceptron is analogous to neuron. And now it is a perceptron model. So very basic perceptron model having 3 input nodes where you can feed your features. If you are having 3-dimensional data set, then from each feature vector, first attribute, second attribute will go there, and third attribute will go there. If you are having n-dimensional data set, then you will be having an input node. And then we are having an output node. So linear combination of these input values along with the weight parameters will go here. And then we will operate an activation function on that linear combination. And then we will get the output. So this is the very basic model. So as I told you, our aim, first I will talk in terms of classification. So suppose I am having patterns from 2 class. So let us say from 1 class I am having patterns like this. These cross, and from another class let me having, oh my god, these circles. So now it is a 2-dimensional data set. If you can see, it is in 2D. So what is my aim? My aim is to find out a hyperplane between these 2 classes of patterns. So let us say this cross is denoting male and these are females, and then I have to separate them. So in 2D, let us say horizontal axis and vertical axis, let us say x1, x2 is your vertical axis. So I need to find out this hyperplane. In 2D, what is the meaning of this hyperplane? It is simply a line. Okay. And then how it will be? This line will be having an equation like w1x1 plus w2x2 equals to b. So what is this w1 and w2? So these w1 and w2 are your weight parameters. Like forget, because I am taking 2-dimensional problem. So you are having x1 and x2. So this will be the weight w1 and this will be the weight w2. Okay. So what, based on the given x1, x2, these pairs of training and your output class, whether it is going to male class or female class, I need to fit this line so that it can separate these 2 class patterns. And this is the simplest perceptron model. Now, when I told you that here you will be having a activation function, what kind of activation function we can have? So we can have an activation function like Heaviside step function, which is gx equals to 1 if x is positive, 0 otherwise, and it will be having this kind of shape. So it is 1 here if x is positive, otherwise 0. So now this value, if it is positive, then the value of this will become 1 if y is positive. Otherwise, it will become 0. Now, suppose you are having two class problem, as I told you, male and female. So I am saying that male is your class 1 and female is your class 0. So now if one of the pattern is coming from, let us say, from male class, and this value is coming 0, then it is not, means what is your desired output? It should come 1, means the value of y should come greater than 0, but it is coming less than 0 or 0. So it will go here in 0 class. That is, actually your pattern is coming from class male, but after computation it is going to class 0, that is female class. So it is a misclassification. So in training, what you will do, you will change these W and B using some rule, and then again you will calculate it. Again you will check whether it is coming positive or non-positive. If it is coming again non-positive, you will again change these parameters, your weight parameters, and B is here bias parameter. And then again you will calculate it. So this process is called training of a perceptron, and you will do it until you will get the correct classification for all the patterns of your training data. Once you are having that, you will get your hyperplane, means this boundary. And once you are having this hyperplane, then you can go for testing, means the pattern, for those you don't know whether it is coming from male class or female class. You will use these trend parameter to predict their actual class. So this is the working procedure of a perceptron. Whenever you are having any question, any doubt, you can unmute and you can ask. Okay. So it should be an interactive session instead of one way.
Hello,
Kind
sir.
of thing. Yes, yes.
Just I want to know the bias, sir. How you are choosing the bias in this problem? The perceptron you're adding with the weight and the input, as well as the bias also you're adding. What is the importance of the bias?
Yeah, what is the importance of bias? Very good question. Now, what this weight will give you? I am writing W1 x1 plus W2 x2. So this W1 W2 will give you the direction of this line. Okay, direction of your separating hyperplane. So whether it will come like this, or it will go like this, or it will go like this, it will give you the direction. But bias will give you the position of this. Okay, whether this line is here, if I am taking this line, or it is here, or it is here. Okay, so position will give you by the bias, because if you are having only W1 and W2, then you can have a direction of the line, and you know we can have infinite line parallel to each other. Okay, if you are having only direction, but bias will give you the position of that line, whether it is here, here, or here, which parallel line is there. So I hope it is clear to you.
Sir, how to because of the bias value, how we can predict that particular what is the position? Just bias is any number, right?
Yeah, bias is a number. So,
Yeah.
suppose you are having first weight 2, so 2x1 plus, let me say, x2. Okay, and then if you are having only this, you cannot make out anything from here. You can only make out that x2 is nothing, just minus twice of x1, like this. Okay, you can have this kind of thing. So from here you can have only slope information. Okay, you don't have any idea about the position. So slope means you are having the direction of that hyperplane. But once you are, if I am having, let us say, it equals to 2, then from here, if this is your, let us say, two-dimensional plane in which you are having your pattern. Your patterns are living in this space. So from here, what you can, how you will see this line? When x2 is 0, what is x1? Put x2 equals to 0 here, you will get 2x1 equals to 2. So from here, you will get x1 equals to 1. So you will having, let us say, x1 1 here, 1, 2, 3. So your line will intersect here. And when you are having x1 0, x2 equals to 2. So suppose it is here. So your this will go like this. Okay. So without this bias, you cannot decide where your line will lie. Okay.
Okay.
So if I take it 4, you will be having a line parallel to this.
Okay.
Yeah. So
So
this is the
how to select, sir, bias? That's my
yeah.
question actually.
I am going to that. Okay. I
Okay,
am
fine.
going to that. How to select W1, W2 and bias. Okay. I will come to that. So here, what is your parameters which you need to tune? Parameters are, sorry, my pen is having some problem, some issue. So these lines are coming. I am sorry for that. So weight plus bias. So for example, in a two-dimensional plane, you will be having W1, W2 and B. These are the parameters which you need to train. Okay. In training phase, you have to find out these parameters. Optimal value of these parameters for all the training patterns. If you are having three-dimensional problem, means your feature vectors are having three attributes, three features, then you will be having W1, W2, W3 and B. And then your hyperplane will become W1x1 plus W2x2 plus W3x3 equals to B. And if you can see, it is simply it is an equation of a plane. So in three-dimensional space, a plane will be the hyperplane. Similarly, if you are having n-dimensional problem, then hyperplane will be W1x1 plus W2x2 Wnxn equals to P. So you have to train, you have to tune these n plus 1 parameters, n weights and 1 bias. So this is the idea. So training means just to tune these parameters to find out the optimal value of these parameters so that you can have your separating hyperplane, so which can separate your different class patterns. Okay. So now how to train this? So the now you have, if you are having n dimensional problem, you are having n plus 1 parameters which you need to tune, and that you will do using perceptron learning algorithm or training algorithm. So the perceptron learning algorithm begins by setting the weights to 0 or to small random value. Generally, when we talk about bias, we initially take bias equals to 1. Okay, bias equals to 1. So here when I am saying weights, weights include weight, all the weight parameters plus bias. And then it then predict the class for a training instance, means for a feature vector from the training data set. Now the perceptron is an error driven learning algorithm. If the prediction is correct, the algorithm continue to the next feature vector. If it is wrong, means you are having misclassification, then as I told you, the algorithm update the weights. So how you will update your weights? It will be updated using this rule. So updated weights equals to old weight plus alpha times, where alpha is a scalar, it is called learning rate. We choose a small value for this, like 0.1, 0.01, like this, and this you have to choose manually into dj minus yj. So here dj is desired output and yj is actual output, means the output which you are getting from your perceptron. So this is the error into feature value. Okay. Similarly, we can train bias. So new bias will become old bias plus alpha times this. Okay. So as I told you here, in weights I am including bias also. So for a clear explanation, I have written it separately. So if the prediction is correct, so if it is correct, means your computed output equals to actual output which you desire. So what will happen? This quantity will become 0. So if it is 0, then alpha into 0 into xji. So this term will be 0 and there will be no change in the weight. Your weight will not update. Okay. So your weight will converge to the optimal value. This is the idea. So we will continue it until unless you will not get to this convergence. Or other stopping criteria may be of the training that number of maximum epoch, means this t, you will start from t equals to 0 and up to what t you want to go, means number of iterations, how many iterations you want to use. So just take a simple toy example so that the things will become clear, and try to visualize it, because if you will visualize it, things will be clear into your mind. So let me take a very toy classification problem to give a better picture of the perceptron training. Suppose I am having a classification problem in which I am having two classes. One is adult cats and another class is kittens. I am representing this kitten class by 1 and adult cats by 0. So what I want, that the output of the perceptron for the adult cats should be non-positive and for kittens it should be positive. If I am taking your Heaviside step function as the activation function. Okay. Now what is my feature? So my feature vector is again having two attributes. One is the proportion of the day that the animal was asleep. So it means how much time the animal was sleeping, and other one that the time of the day that the animal was grumpy. So for example, if I take my first training vector, first animal, it spent 0.2 times of a day for sleeping and 0.1 time of a day for grumpy. Similarly, for second animal, I am having 0.4 and 0.6. So what is my training data? Training data is, you can write like this: 0.2, 0.1, and its actual class is 1. So this is your first pattern, training pattern. So here this is your feature vector 0.2 and 0.1, and 1 is the class, that is label of this pattern. My next pattern will become 0.4, 0.6, and then again it is belonging to class 1, and so on, and finally I am having 0.7, 0.9 and class 0. So I am having total 4 patterns in my training data. So training data should have feature vector as well as the actual class information. And from now, using these data, I will train the perceptron and I will see where my hyperplane will come. So if I plot it in a two-dimensional plane, and on the horizontal axis I am having sleeping, and on the vertical axis I am having time that was spent being grumpy. Then if I plot these, because it is two-dimensional features, so I can plot them in a two-dimensional plane. These are the patterns, pattern 1 and so on, pattern 4. So what is the objective of training? To find out a hyperplane, we separate these two classes. That one side of that line, you are having class 1 pattern, that is your kitten, and other side you are having the adult cat class. Now this line may be here, this line may be here, this line may be here, this line may be here. Okay, that will depend on your training procedure and how you are trained. You are making the training. Again, you are having two important concepts here. One is called overfitting, another one is called underfitting. Okay, so I will discuss about that from here itself so that you can get a clear picture. So suppose you are having one pattern here. Okay, I am adding one more pattern in my training data from class 1. So you are having this particular pattern here, and then you are trained it. So now what you need? You need your hyperplane should come here, somewhere here. Okay. But suppose while testing, you are having these patterns, some of the testing patterns like this. So what will happen in this case? You have trained based on the training data. You have minimized the training error. You have given more emphasis to fitting your hyperplane. But you are having more testing error in that case. But suppose instead of this, you have taken a hyperplane here during the training. So here, if instead of this green hyperplane, you take this maroon hyperplane, you are having training error that one of the pattern is having misclassification. But during the testing, you are having 100% accuracy. Okay. So earlier case, taking this kind of hyperplane is called overfitting. Okay. So that is the concept of overfitting. Whereas if you are having this kind of hyperplane where you can have some training error, but during the testing you are having more accuracy, then that is called your underfitting. So you have to make a balance in overfitting and underfitting in your classification model. So let me start with training of that perceptron using that example. So instance 0 means my first feature vector. Here I am initiating my weight with 0, 0, 0. So this is W1, let us say W2, and this is B. That is your bias. Now what is your first training? Sorry. Sorry. So you will, what kind of model you will be having here? First, this is your first input. So this column, second input unit, and your bias. Now you will be having your output unit. It will connect here, it will connect here, and it will connect here. So let us say it is X1, X2. So X1 bias B. So bias I will take always 1. And now it is, let us say, W1, W2, and W3. I am having like this. W1 X1 plus W2 X2. Or let us say this weight is my B plus B equals to 0. This kind of thing. So now come to your data. So I am taking initially all three weights 0 because you are having 3 connection from input to output layer, 2 for feature and 1 for bias. And what are the value? 1 for bias, 0.2 and 0.1. So if you go here, 1 for bias, so I am having a column bias here. 1 for all patterns, this bias I will take 1 initially. So 1.2.1. This I have taken 1.2.1. Now 1 into 0 plus 0.2 into 0 plus 0.1 into 0 will come out to be 0. Now according to, so what you are having? You are coming here with 0. Now you will apply your activation function on this 0, which is your heaviside step function. So it is not a positive, so it give you 0 only. Because if it is positive, it will give you 1, otherwise it will give you 0. Hence, what is your prediction? 0. But actually, from which class your first pattern is? It is from kitten class, for which I have assigned class 1. So prediction is 0, target is 1. So it is a false classification. So what I need to do? I need to update my weights. So I will update my weights, and updated weights will become 1.2 and 0.1 according to that rule. Wt plus 1 equals to Wt plus alpha times error into Xij. From that I got this particular updated weight. Now I will go to second pattern. I will repeat the same process. Here I got the value of which coming to the output node as 1.14, and if I take the heaviside step function, I operate in this value, it is a positive value, so answer will come 1. So prediction is 1, target is 1, so true classification. So what will happen? No change in the weight. Similarly for second and third. So again, when you will go to third, you see it is coming here 1.23, and which is giving you class 1, but actual class of last pattern is, which is a adult cat, is 0. So again, it is a wrong classification, so false. So two of the patterns are going to true class, while two are false. So I will go to next iteration of the training, and I will continue it until unless I will not get the all correct classification. All these should be true, means this should be 1 1 1 1 1 1 and 0 0. So I will go to second iteration, and again same process I will repeat. So again I am having false, true, true, false. I will go to third, and here you can see false, 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 true. Even my hyperplane go to other position such that I am getting 3 misclassification. But no problem, I will continue it, and when I will go to sixth iteration, I will see that all training patterns are in correct class. So all are true. And this is my final weight value. So W1 is, sorry, bias is 2, weight for bias is 2, W1 is -1, and W2 is -1.5. Okay. And hyperplane will become x1 plus 1.5 x2 equals to 2. So now see visually this. So here you can see in first iteration in EPO1, you can see I am having this hyperplane. So separating boundary line is given by different colors, boundary of the different colors. And here, this is the pattern which is from the class 0, and these are the patterns from class 1. Then second iteration, third iteration, And finally, you can see in 6th iteration that these 3 patterns, those are your kittens, are coming into kitten class, and this is in the adult cat class. So this is my final boundary. And during training, I have established this hyperplane. Means this hyperplane means I have got W1, W2, and B. Now what will happen when I will be having a testing pattern? So for testing pattern, I don't have the true class. I don't have the true class. So what I will do, I will just check that suppose that new pattern sees something, let us say 0.4, 0.6. 0.4 time for sleeping and 0.6 is the time for being grumpy. Then I will calculate this value 0.4 into 1 plus 0.6 into 1.5 plus B is 2. And this value, whatever it will come, sorry, these are minus 1 and minus 1.5. So 0.4 into minus 1 plus 0.6 into, so let me write here, 0.4 into minus 1 plus 0.6 into minus 1.5 plus 2, and I will check whether it is a negative value or positive value. Okay, and if it is coming positive, it will go to class 1, that is kitten class, and if it is negative, it will go to adult cat class. So this is the overall idea of a perceptron. Here again, how to implement it in Python. So I have taken a bit bigger problem. So we will train a perceptron to classify documents.
Sir, I have some query.
Yeah, please.
Sir, just now you explained, sir, the weight we updated using the back propagation. What concept you used? Weight you updated, right?
Yeah. So
Which
gradient descent. It is a single perceptron. I am not started multi-layer perceptron. There we will use back propagation. Okay. Yeah, I will discuss
And
about
one more query, sir, non-linear data, how it will handle? For example, as per your problem, is it classified?
Yeah, it is a perceptron. A perceptron is linear classifier. So I am coming to that. For that we will use multi-layer perceptron.
Okay, sir. Thank you.
Yeah, don't worry. All these issues I will discuss. Okay. So this is a news group dataset consisting of 20,000 documents sample from 20 Usenet news groups. And this data is coming from sports newspapers, from hockey, baseball, and auto type of thing. So I am having these 3 classes. And how many? 20,000 samples. So how I will extract the feature? So for feature extraction, I will use a technique that is called bags of words. And in Python, I am having tf-idf weighted means hashing vectorizer for that. So this is the Python code for this problem. So here I am fetching the data from the in my Python. Then these are my metrics. I will talk about F1 score and classification report. I will talk about it. Then these I am importing my perceptron from sklearn, or you can import from scikit-learn also. These are your classes: hockey, baseball, and autos. This is your training data you are designing. Then train data, testing data, you have done it. Perceptron, number of iterations, how many you need. So here I am setting 100 iterations. This is my learning rate, that is your alpha 0.1. So these two things you need to decide based on your problem. So you can play, means how much training accuracy you need. Based on that, you can design these two things. Then you are fitting your classifier, means training your classifier, training data and target. And then you are predicting it on the test data. So if I run it, you can run later on. I will share the slide. You can see I am getting these three classes 0, 1, 2. So let us say this is for hockey, baseball, and autos. So precision is coming 0.89, 0.87 for class 2, and 0.79 for class 3. Now what do you mean by precision here? Precision is nothing, just your true positive upon true positive plus false positive. Okay. So if you are having 100% true positive, here true positive means a pattern from class hockey is classifying in class hockey. That is your true positive. But if a pattern from class baseball is classifying in class hockey, that is false positive for your class hockey. Similarly, we can have recall. So recall is nothing, just same true positive upon true positive plus false negative. Okay. So for hockey class, let us say if a pattern from hockey class is classifying in hockey class, then that is your true positive. But if a hockey pattern is classifying in any other class, that is false negative for this class hockey. So I am having recall, and then F1 score is nothing, just a weighted average of precision and recall. And this F1 score is nothing, just 2 times precision into recall upon precision plus recall. So it is a weighted average of these two. And now if you see this data without hyperparameter optimization, means we have done only, we have not using any hyperparameter optimization thing, but still the perceptrons average precision, recall and F1 score are 0.85, 0.85, 0.85, means it is having 85% accuracy. Okay. So this is about the perceptron, and I told you that in Python you can easily import it from scikit-learn or from the linear model of the scalar, and you can import it and you can play with some data set. Now come to nonlinear problems. So if you are having, let us say, this, let us say A, B, 1, 0, 1, 1, 0, 0, and 0, 1. Then the A and B will be, and here you are having A and B. So if 1, 0, 0, 1, 1, 1, 0, and 0. Sorry, 0. So you can see this is your point 0, 0. This is a point 1, 0. This is a point 0, 1 in 2D. And this is the point 1, 1. So if you calculate the end between these coordinates, you can see that this is 0, 0, 0. And when it is 1 and 1 will come out to be 1. So here I can classify this problem easily using a, so you can follow my mouse. I can classify this problem using a linear classifier. That is just using a line. Below the line you are having 0 and above the line 1. Similarly for not and or, but when you are having XOR problem, can you separate 0 and 1 using simply a single hyperplane? I mean a single line. Can you find out a line? Above the line you are having red, means your 1, and below the line or you are having 0. You cannot do. Here what you need at least 2 hyperplanes. That is for the first hyperplane. So let me say hyperplane 1. Below the h1 you are having 0 and above h1 you are having 1, and then you are having h2. Below h2 you are having 1 and above h2 you are having 0. So it is a non-linear classification problem. One of the basic example of non-linear classification problem. A non-linear classification problem is a problem where you cannot separate the different class patterns simply using linear hyperplanes. Okay, means you cannot employ a linear classification model. So for real data, generally we encounter this kind of problems only. So for that, we extend this perceptron to neural network that is called the basic neural network, that is multi-layer perceptron. So that is the motivation for why we are going from perceptron to multi-layer perceptron. So the multi-layer perceptron is the one of the most commonly used artificial neural network. The most popular neural network is multi-layer perceptron, and mathematically also it is there that it is a universal classifier. It can solve any classification problem. The name is slight confusing, that is a multi-layer perceptron is not a single perceptron with multiple layers. No. Instead, you are having multiple perceptron arranged in different layers. So instead of one perceptron, we are having multiple perceptron. And why we are taking these multiple perceptron? Because each perceptron will give you a line. So for example, for solving this problem, I need at least 2 perceptron, one for this H1, another one for H2. Okay, so that's why multi-layer perceptron. That is multiple perceptron arranged in different layers. And it makes a directed acyclic graph, means you are going from input to output. You are having input layer, then you will be having some hidden layers, and then at the rightmost you will be having your output layer, and the flow will be from input to output. So generally each layer is fully connected to the subsequent layer. The output of each artificial neuron in a layer is an input to every artificial neuron in the next layer towards the output. Now, a multi-layer perceptron should have at least 3 layers: input, hidden, and output. And I told you at least. It may have more than one hidden layer also. Means like nowadays deep neural network are having thousands of hidden layers. Okay. So it can have any number of hidden layers. But one input, one output, and at least one hidden is compulsory. Then you can add more hidden layer. The input layer consists of simple input neurons. The input neurons are connected to at least one hidden layer of artificial neurons. So from input, you will go to first hidden layer to second hidden layer, and so on. And then finally output layer. Now, the important thing is why we need this back propagation, that the hidden layer represent latent variables. The input and output of these layers cannot be observed in the training data. Okay. And in the last hidden layer, that is the rightmost hidden layer, is connected to an output layer. So for example, it is a model which is having input and one hidden layer and output layer. How many perceptron you are having in input? How many nodes? 1, 2, and this is for bias. In hidden, you are having 1, 2, 3, and this is for bias of the hidden. And then output 1 and output 2. Now, like you have used Heaviside step function as the transfer function, here again for each hidden layer and output layers, you will be having transfer function or activation function. So these transfer functions may be, they are nonlinear functions. One can be an hyperbolic or sigmoid or logistic function. So these are two examples. There may be others also. Like in deep neural network, we use rectified linear ReLU. So as with other supervised model, our goal is to find the values of the weights and bias that minimize the value of a cost function. And we will design this cost function based on the your model. Generally, we use mean square error between the target and computed output as the cost function, so that it will become a convex function and you should converge to global minimum. What is the algorithm for training? One of my dear friend asked. We will use back propagation algorithm to, along with the gradient descent to minimize the value of the cost function. Okay. Now we will try to understand the concept of back propagation, because this is the most confusing thing, or let me tell you, most important thing for the multi-layer perceptron. So let us learn about back propagation. So we will step through training a multi-layer perceptron, that is feed-forward neural network, using back propagation learning algorithm. So this network has two input nodes, two hidden layers. Both of them are having three hidden nodes. So input are 2, one for bias. Then you are having two hidden layers, each one having 3 nodes and one for bias. So bias we will take different separately also. So let me take like this only. And then you are having two output units. So two output units. So basically model is like this. So bias I will take here itself for each of the node, for each of the perceptron. So two input, then three nodes in each hidden layer, and then output layer. And then what will happen? First, I will give some input here. Let us say I am giving x1 and I am giving x2 here. Or let us say input 1 and input 2. So first what I will do? I will compute the activation for the hidden one. So what is my hidden one? This is hidden one node. Hidden 2, hidden 3, hidden 4, hidden 5 and hidden 6. So what will come here? It will come input 1 into weight 1 plus input 2 into weight 2 plus bias weight 1, which will come here input of first hidden. So here what is? This will be the input. B1 plus W1 x1 plus W2 x2. If you are putting x1 x2 here and B1 is the bias. This will be the input of this. What will be the activation of this? This input will go to activation function. The activation function you can take either tan hyperbolic x or sigmoid. So once you take it, it will become, let us say G is my activation function. So activation of hidden one will become G of bias weight 1 plus weight 1 into input 1 plus weight 2 into input 2. Now what will be the activation of hidden 2? If I say, let us say it is weight 3 and weight 4 and let us say bias weight 1, bias weight 1, bias weight 2. So what will be the activation of hidden 2? Anybody of you?
What's that?
Activation of this hidden 2.
Yeah, that is
G of
G of
bias
input 1 into
input 1 into weight
W3
3 plus
plus
input 2 in, yeah,
input
input
2
2,
into W4 plus bias of W2.
yeah, wonderful. So this will become like this: bias W2 weight 3 into input 1 plus weight 4 into input 2. So similarly, we will be having for third bias weight 3 plus W5 input 1 plus W6 input 2. So in that way, we have come up to here. Now we will come to hidden 4, activation of hidden 4. So activation of hidden 4, you can see here, it will come here, and then I am having these 3 connections. Those are coming here. So let us say weight 7, weight 8, and weight 9. And then I am having bias 4. So what will be the activation of this hidden 4? It will become G of bias weight 4 plus W7, that is your weight 7 into activation of hidden 1, whatever output of the hidden 1, plus weight 8 into activation of hidden 2 plus weight 9 into activation of hidden 3. So it will come like this. Okay.
That sounds
Any?
query, sir. यहाँ पे.
Yeah, please.
Sir, you are taking the bias here and using the different hidden layers also, and you are
Yeah.
taking each and every neuron in the hidden layer. You are taking the bias. All those
Yeah.
bias are same or different. Each and every layer, the bias is changing or same.
Initially, you can take random value, or you can take all one. Okay. During the training, they will update automatically. Okay.
Okay.
Yeah, but they are different because every node is a perceptron here. Every hidden node is a perceptron here. So for each perceptron, you are having one bias. Getting my point?
Okay, sir.
Hello. Yeah. Initially, you can take random value for them. Randomly, you can initialize, or you can initialize all with 0 or all with 1. Then it will be updated. So this is hidden 4. Then similarly, we will be having hidden 5 and hidden 6. And then what is output 1? So activation of output 1 will become bias weight 7. I am taking for output layer plus weight 16 into hidden 4 plus weight 17 into hidden 5 plus weight 18 into hidden 6. Okay. So this is your output 1, and then similarly activation of output 2. Once we are having this output, I am having my target output also. So from here what I will do, we can calculate the error of the network at these output units. Okay. I cannot calculate any error on the hidden layers because here these are latent. I don't have any output here, a target output here. For target output, I have for output layer only. So from here, I can calculate error here and error here. Now I will back propagate this error towards the hidden layer to update the weights. Okay, and this is called back propagation. How we will do it? Just see. So we will begin with output 1. So in order to update the weights, we must propagate the network's error backwards through its layer. Because you have calculated error on rightmost output layer. So now you will go towards the left side, means in backflow. Here error is equal to the difference between the true and predicted output multiplied by the partial derivative of the unit's activation. So let us calculate error at output 1. Means here what will be the error? Here we will be having the partial derivative of output 1, whatever activation you got here, multiplied with true 1 minus output 1. Similarly, I will calculate error at output 2. So error at output 2 again, just G dash output 2 multiplied with true 2 minus output 2. Now I am having error here. Error output 1 and error output 2. From here, I will calculate error at hidden 4. How I will do it? So error at hidden 4 will become again G dash of hidden 4, that you know hidden 4 value that you have stored somewhere, multiplied with what was the weight? Weight 16 was there. Weight 16 into error of output 1 plus weight weight 19 of error output 2. So in that case, in this way you are having error at hidden 4. Similarly, you will calculate the error at hidden 5. What will be the error at hidden 5? It will become G prime of hidden 5 multiply with, it was the weight 17 into error at output 1 plus weight 20 into error at output 2. So in that way, you will calculate for 6 also, and then I will calculate for 1, 2, 3. So for 1, how I will calculate it? G prime of hidden 1 multiplied with weight 7 into error at hidden 4 plus weight 10 into error at hidden 5 plus weight 13 at error at hidden 6. Okay, that will become error at hidden 1. Similarly, I will do for hidden 2 and hidden 3. So you can see here, I go from input to output, then I have calculated the error at output, and now I am propagating that in backward direction to get error at hidden layers. Okay, in that way we compute the error of the first hidden layer. We can now use these errors to update the values of weights to minimize the error. So we will first update the weights for the edges connecting the input unit to hidden one, means these two weights. Because now I am having error here, error at hidden one. So using this and old weights, whatever it was there, I will update these weights. So we will increment the value of weight connecting input 1 and hidden 1 by the product of learning rate, error of hidden 1 and the value of input 1. We will similarly increment the value of weight 2 by the product of learning rate, error of hidden 1 and value of input 2. And in that way, we will do it for all the layers. So how to update weights for hidden 1? So first I will update this bias weight 1. So bias weight 1 will become bias weight 1 means bias weight 1 new equals to bias weight 1 old plus here is learning rate parameter into error rate hidden 1. Weight 1 new will become weight 1 old plus learning rate into error rate hidden 1 into input 1. And similarly weight 2 will become new weight 2 will become old weight 2 plus alpha time error rate hidden 1 into input 2. Here I am not multiplying with input because bias I have taken 1. So in that way I am updating these. Similarly update weight 3 and weight 4, weight 5 and weight 6. So bias weight 2, weight 3 and weight 4 you can update using the similar rule. Then for hidden 3 means weight 5, weight 6 and bias weight 3 I will update. Now how to update weights for hidden 4? So bias weight 4 will become bias weight for old plus learning rate into whatever error you were having at the hidden 4. Bias weight 7 will become old weights, sorry, not bias weight 7, weight 7. It's old weight 7 plus learning rate into error rate hidden 4 into hidden 1 because it is the connection. Weight 7 is connecting hidden 1 to hidden 4. And similar thing you can do for all the weights. Like here for weight for output 1, you can update all these weights. So in that way you will update all your weights. And again you will calculate the error. If error is more than a given threshold which you have set, you can again back propagate it. And then you will calculate the error rate, output 1, output 2, all the hiddens, and then you will update your weights. So this process will iterate until unless your error will not come into the given threshold. And this is the training of multi-layer perceptron. Where each of these are giving you a hyperplane. And then using this you can solve your non-linear classification problem. Like suppose you are having suppose you are having this kind of problem. My God, it's become very sensitive. This kind of problem. So how you can create hyperplane like this, then like this. Oh my God, this become very. And then you can have like this. Okay. So you can solve using several hyperplanes, those you have generated from the multi-layer perceptron. Means what I want to say, you can have non-linear classification boundary. It will come like this. Something like this. Means. So this is called back propagation training algorithm for multi-layer perceptron. Once you are having all the bias weight and weights, whenever you have any pattern for which you don't know the class, you will put it, you will calculate output 1 and output 2. Okay, if whatever activation will be more, whether output 1 or output 2, it will, if output 1 is more than output 2, it will go to output 1 class, otherwise it will go to output 2 class. That is winner takes all kind of thing we follow here. So as I told you, we will repeat the training until the model converges or another stopping criteria is satisfied. So let us see the Python implementation of JOR problem first. A very simple, which I told you. You need two perceptron. So let us train a multi-layer perceptron to approximate the XOR problem. First, we will create a toy binary classification dataset that represents XOR and split it into training and testing sets. So just for I have import this train test split function, means it will randomly split my data into training and testing sets. Then from a scalar neural network, I am importing multi-layer perceptron classifier. Earlier, from a scalar linear classifier, we have imported perceptron. But now from a scalar neural network, I am importing multi-layer perceptron classifier. Created 1000 patterns from 0 and 1 class, and then thousands points of 0, 1, 1, 1, 1, 0, all those kind of things. Then I have split these 1000 points into training and testing data randomly. Next, we initiate multi-layer perceptron. We create an instance of multi-layer perceptron classifier. We specify the architecture of the network through the number of hidden. So how many hidden layers you need, that you have to specify, which takes a list of the number of hidden units in each hidden layer. We create a hidden layer with 2 units that use the logistic activation function. And the multi-layer perceptron classifier class automatically creates 2 input unit and 1 output unit based on this. In multi-class problem, how automatically it will do? It will do based on your input and target data. Here it will be one dimensional, so 1 output unit. Here it is 2 dimensional, so 2 output unit. Only thing you have to specify number of hidden layers and their nodes in each hidden layer. In multi-class problems, the classifier will create 1 output unit for each of the possible classes. Like here, you are having only 1 output. 0, 1 means 1 output node. But if you are having multi-class, let us say 10 classes are there, then you will be having those 10 output nodes. So this is the code, rest of the code. So I have create an instance. I am having 1 hidden layer which is having 2 nodes. My activation is logistic, algorithm is stochastic gradient descent, and random state 3. Now I am fitting, means train, x train and y train. X is input feature vector, y is actual classes, and then I am running this. Yeah, so you can run this code. I will share these slides and you can see the output. So that's all about neural network and Perceptron from my side. You can ask some of the questions.
Sir, what are the libraries we can learn for the implementation of the neural networks?
Scikit-learn,
Only
sklearn or
that's sufficient.
sklearn.
That's sufficient SQL.
Yeah, sufficient, more than enough. NumPy obviously you have to learn.
Okay.
NumPy
Sir,
you have to for
how
vector.
different from sklearn?
Hello, yes.
Sir, how Keras is different from sklearn? Sir, for deep learning purpose, we use Keras, no?
Yeah, because there you are in TensorFlow, Keras, there you are having pre-trained classifiers. Okay, pre-trained neural networks. But sklearn is basic for machine learning, not for deep learning. Okay. If you want to implement support vector machine neural network,
Sir,
k-means clustering or any other classifier, then you have to use this. You have to learn sklearn.
sir, actually, I want to work on 3D convolution neural networks. So, what are the skill set required? Actually, I'm doing the just I started the working, but implementation I have to do the 3D convolution neural networks I have to do. Lung cancer detection, my problem, PhD.
Okay. Then for that you have to see what is your means which network is you can use means pre-trained like VGG, LXNet or all those kind of networks we are having.
Okay.
Okay. So that will depend on your data. Okay, your problem. So you can play with those using TensorFlow, and then you can, because implementation is very easy.
Sir, sir, in ANFIS, that is for MATLAB version, only one output is available, sir. If I'm having in mechanical, if you are doing condition monitoring, we will have more output sensors. If I have more output sensor, how can?
In MATLAB, you are saying about neural network toolbox.
Yes, sir. ANFIS, neural fuzzy interference system.
That I didn't see, but I think in neural network toolbox you can have more output.
Yes, sir. In neural, I know, sir. What you are telling is correct. And in ANFIS, that is artificial neural with the fuzzy interference system.
That I don't have much idea about that. Okay. I will ask and you can write me an email and then I can.
Okay, sir. I will contact you in mail.
Sir, kindly provide your email ID, sir. Is it better for us for future guidance?
Yeah. Let me tell you that I am always open for discussion, collaboration, all those kind of things. Okay. So let me share some of my detail with you. So
Okay,
that, okay. So.
Sir, Sanjeev sir, there is a question from the participant asking that I want to learn math behind machine learning, maybe mathematics behind machine learning and deep learning. Suggest me some good books from where I can learn.
I am coming to that. Okay, just wait. Yeah, I am coming to that. Just wait. Let me share it again.
Yeah, meanwhile, I will share my views on the previous query. Someone asked about medical data set. As medical, you are talking about lung cancer, no, sir? Lung cancer input images are
yes, sir.
Input in the form of images, no? So the main challenging task for working on medical data set is original data set.
Okay.
Once you have the original data set, fortunately, due to advancement of the computations in both sessions of hardware and software, we have the pre-network models like AlexNet, DenseNet, VGGNet. These are the networks which are trained on thousands, sometimes millions of the data set, experimented and improved the performance of those nets. By make use of those nets, we can conduct the experiment on our data set in line with the target what we have fixed and to be generated.
Okay.
Deep neural networks are VGGNet, DenseNet, AlexNet. But the fuel for all experimentation in MLDL is data, original data. You are very fortunate if you have the data set in medical health.
No,
Medical
sir.
domain,
Not yet collected, sir. Data set is not yet collected.
that is the important task that you need to focus on first, than focusing on the methodology to be used for experiment.
Okay.
In addition to Professor Srinivas, that you can alter the architecture of those networks also according to your problem.
Yeah, customization, soft matrix, max pooling.
Yeah, you can add more layer, you can do that. Okay, and then you can apply on your problem. So if you can see my screen, you can see this Google page.
Yes, sir. Yes, sir.
So if you type on Google Mldlt FM, this is my home page. Okay. So from here you can see about my. So when I talk about teaching, so one of the questions was like if you can see here, we have developed a course, Essential Mathematics for Machine Learning. So in this course, this is a course for NPTEL MOOC platform, and all the videos are available on YouTube together with transcript. Okay. So you means hand notes, PPT, all are there. So you can learn from there. So all the lectures are freely available, whatever topic you want. So we have tried to cover all the topics.
And
Whatever.
implementation also available, sir?
Yeah, implementation in terms of NumPy and Python implementation.
Yes, using Python.
That is not there, but we are working on that, and that will come from the next January session. Okay.
Okay, sir.
So some more video we will add that how to implement all those concepts in Python. Okay.
What is this, sir? Malik FRNE, no?
Malik FM. If you type or you type Sanjeev Kumar IIT Roorkee, you will find this website.
Okay, sir. So what faculty list I seen, sir, but not visible there.
I will share you. I will share you the speaker's URL.
Okay, sir. Fine. Okay, sir. Fine.
Okay,
Thank you.
so you can see more details.
IIT Roorkee will find it.
Okay, sir. Fine.
Okay.
Thank you.
You can see from here about my publications, or if someone is interested of similar kind of work, one can. Okay.
Okay, sir. Fine.
Yeah, my research project. So from here you can see, and you can write me anytime. Okay. On my email, which is
this is the URL I got from the Google search bar.
Yeah, sanjeev.kumar@ma.itr.ac.in, or in Gmail it is malikdma.
Okay, sir. Fine.
Yeah. So any other questions?
Yeah, the session is open to resolving the queries from the participants. I am requesting the participants to unmute yourself and clarify your doubts.
Yeah, this Vijay Sharma and Harishankar bias will be updated as per like other weights only. Okay, only bias value is always 1, and then there are weights which connect bias to other layers, other nodes. So those will be updated like any other normal weights using the gradient descent. This old weight plus learning weight times error into input. And Vijay Sharma asked, yeah, you can take bias weight 1 and bias weight 2 same in the beginning, but later on it will automatically updated.
So what is the range of the bias, sir? 0 and 1 only?
You can take anything, but it is better to take around 1 or 0. Okay. Yeah, otherwise your it may happen that your problem will take more iterations to converge. Okay, generally we start randomly and randomly between 0 to 1.
Sir, input should always be normalized. Is it?
Yeah, that is always better.
Okay.
That is always better. You normalize input and output. Output means classes are there, so no need, but input you can always normalize, because even though if you see this sigmoid function, so this it is a bounded function between 0 to 1.
Okay.
So it is better always normalize 0 to 1.
Okay.
Normally, bias is the term used to fit your model to the given data set, sir.
Okay.
To fit your data to the given data set. That might be plus or minus.
Yeah, that's what means. It will decide the position of the hyperplane. We will decide position based on the bias. Other weights will give you the means bias weight will give you the position. Other weights will give you the direction.
But what value of the bias we are taking, that will affect our model, because in the calculation we are taking the value.
No, that is bias value will always take 1, but bias weight can be anything.
Okay.
Yeah, bias value will be 1, because that will be the bias weight, which will decide. Because if I am taking bias value 1, then 1 into whatever weight will be there, that will be the give you the position intercepts.
Okay.
Yeah.
So we can implement the unsupervised learning mechanisms also, no, using perceptrons.
Yeah.
Like self-organized map, like that concept.
Yeah. All are there in SQL. Okay.
Okay, sir. Fine.
Yeah.
Sir, is bias needed for every neuron, sir, in the hidden layer?
Yeah. We have taken for every neuron.
No, but as you said, if it is just one, then it doesn't make any sense, no, sir. Like 1 multiplied by anything is that value itself. So if you take bias as 1,
Yeah.
so it doesn't affect any of the parameters at all in any sense. If I take bias as 1.
No, if you take bias as 1,
The weight is
hello,
this.
weight is there training.
Sir, bias is always 1. If weight is 0.2, 1 into 0.2, 0.2.
Yes, sir.
0.2. So
Bias
it will
then weight is 0.3, that will become 0.3. It is not always 1. Not same to all the neurons.
Automatically it will update. You can see one example. You can use Python, or you can use hand calculation, and you can see in each iteration it will weight will be different until unless it will not converge.
Like other weights, how they are updating. W1, X1, W2, X2. How the weights of W1, W2 are varying with respect to X1, X2, like that, the weight for the bias is also changing. I hope I am clear.
Yeah. So if no more question, so I think.
Namaste, sir. One question, sir. This
is
Anant Narayan speaking from Hyderabad, sir. Sir, you are speaking perceptron in machine learning algorithm, sir, for epidemic outbreak prediction and healthcare for imaging. Which perceptron will be more suitable?
No, multi-layer perceptron, and you have to go either MLP or deep neural network. Perceptron will not work there.
Yes, sir. Sir, in deep neural networks, you are speaking in that one. Which neural network, sir? Convolutional or recurrent neural network or any other neural network?
That will depend on your problem. Okay.
Yes, sir. Means the question. Yes, sir.
If time series related requirement, then it is recurrent. Time series related.
if dynamical data is there, temporal data is there.
Categorical data like images, then AlexNet, DenseNet, VGGNet.
Yes, sir.
If you are talking about medical data, and it is, if you are considering categorical rather than the time series data, then the VGGNet or DenseNet is enough. If you are considering to the time series data, continuous, then RCNN, recurrent convolution neural networks.
Sir.
Yeah.
Thank you, sir.
So that's about the queries part. So thank you, sir. Thank you, Dr. Sanjeev Kumar, sir, for delivering this talk. And thank you once again for accepting our invitation and delivering this talk about neural networks for image classification. I think this session was full of valuable knowledge. Thank you. Thank you, one and all.
Thank you. Thank you very much.
Thank you, sir.
Yeah. Personally, I should thankful to you, sir, Dr. Sanjeev, sir.
Bye, Srinivas. And sorry, because I preponed it because
no
I need to run daily now itself. Okay.
Everything will not be in our hands, sir. I can.
Sure.
Yeah.
Thank you very much.
Thank you very much. Though you're hurry with other activities, you spent 2 hours of time with us and shared the deep knowledge with us. I should thankful to you.
Thank you very much.
Yeah, that's about, dear participants, that's about today's session. So we have the sessions regression, logistic regressions, and neural networks for image classification by Dr. Ramesh and Dr. K. Ailaya and Dr. Sanjeev Kumar. That's about today's session. So yeah, you can leave the meeting now. So we welcome you for tomorrow's sessions. Thank you.
Someone asking the doubt. What's the doubt, sir?
Yeah. Sir, please continue. If you have any queries, you can, yeah.
Ma'am, tomorrow scheduled as it is or any changes?
No, sir. Tomorrow's schedule is as Sanjeev Kumar sir is having some another work. So we just preponed sir's sessions to now afternoon session, sir.
Okay, thank you.
Actually, Sanjeev Kumar session is scheduled tomorrow, sir.
Okay.
Tomorrow he is having inspection at IIT Roorkee. That is why the session is preponed to today. And due to sudden adjustment, instead of 2, he requested us to start at 2:30.
Okay,
sir.
Okay.
Tomorrow, as it is, sir. As morning, we will start with Dr. P. Rajendra from IIT Dhanbad. Is delivering session on decision tree classification and adversarial machine learning, followed by Dr. G. Madhu, sir, is going to be handle a session on importance of the convolution neural networks.
Yes.
And then we will have the lunch break. After that, there is a session from Dr. C.H. Ramalinga Swami from NIT Warangal. He's going to be delivered the session on ensemble learning.
Okay.
This is the schedule for tomorrow. If everything goes on well, this is the schedule to be followed.
Okay, sir. Thank you.
Yeah, thank you. అంటే ఆయన కంప్యూటర్ సైన్స్ ఫ్యాకల్టీ కాదు. అంటే ఈయన మ్యాథమెటిక్స్ బ్యాక్గ్రౌండ్, వీళ్ళు అడిగేది ఏంటంటే కంప్యూటర్ సైన్స్ అప్లికేషన్స్.
అందుకని
సార్ మ్యూట్ చేసుకోండి.